ഇതോ
ഒരുപാട് പോയാൽ ഒരു
the wires and all
You are very nicely saying everything out loud.
sit make us comfortable. इस रूम में ये सब वो एक्सपीरियंस में इधर केयरफुल हियर
Where is 50 years? And the height and the high height.
പ്രോഗ്രാം സ്റ്റാർട്ട് ചെയ്യുമ്പോൾ മിനിസ്റ്റർ
അല്ല ഇത് എനിക്ക് ചെറിയ ഡൗട്ടുള്ളത് ഓക്കെ ആണോ ഹൈറ്റ് മാക്സിമം ആണ് വെച്ചിരിക്കുന്നത് ഇനി ഹൈറ്റ് കൂട്ടാൻ പറ്റുമോ മാക്സിമം ഹൈറ്റ് വെച്ചിരിക്കാം നടുക്കത്തതും നല്ല ഹൈറ്റിലാണ് ഇരിക്കുന്നത് അയക്കാം ഇതാ മാക്സിമം. ഇല്ല, അത് സെറ്റാണ് മാക്സിമം. ചരിഞ്ഞല്ലോ ഇപ്പം. ചരിഞ്ഞല്ലോ.
അത് ഫിക്സ് ചെയ്തോ? ഇതൊന്നും ആ ഓക്കെ.
Uneven, very uneven. I like heterogeneity, but not too much polarization. Come on, spread this side also. Yeah, spread this side as well. Hey. I'm a chemist, but polarization is there. Physics aspects. I'm not opposed to it.
That's what I will be discussing for 4 hours.
Every other day my check gets bounced because my signature was deposited in the years time. It's time to signature changes, but then the same
So pick up those.
Good morning all. It's my pleasure to invite everyone and also introduce about the event. So the respected director and deputy director, invited speakers, and also Professor Anil Shaji, advisor, School of Data Science, and all my faculties. So this event is like welcome to the AI Impact Presubmit Event. Mainly we focus on AI for Science, organized as part of the AI Impact Summit 2026 under the India AI mission of the Ministry of Education. So in this event, we will have technical talks by faculty members from our ISER TVM. They're prepared to introduce about computer vision based research and also AI related research that we will do in the first session. Then followed by we have speakers from academia, then also industry, mainly covering the AI application across diverse branches of science, as well as the standalone AI focused research initiatives at ISER TVM. Then after that also we have interactive section. We planned a panel discussion. Mainly the student can talk with the experts, then also discuss about the future job opportunities and also relevant AI related questions. So then in the panel discussion we have industry participants from Adobe Research, then Kerala Police, then Sri Chitra Research, then IIST, then also our School of Data Science faculties. So mainly the discussion focus on real world AI application, then industry perspective and opportunity for collaboration between academia and industry. So this will be the overview of today's event. So I invite Dr. Priyanka, Head of School of Data Science, for introducing about our school.
Warm welcome everyone. So today we have gathered for a event, the first of its kind event in ISER TVM on AI. So this is under the India AI mission initiated by Government of India. So before going into the main event, I like to for the external students who came here and who the external speakers, I like to give a very brief overview of our school. So this school actually initiated academically from 2020, and since in ISER setup for 2 years we do the foundation courses. So the data science as a major student, we got our first batch from 2022 onwards. And that time we have only one faculty in 2022, but now as of today, so as of today, the faculty strength increases to 10, and this is under the flagship of I-Squared Data Science program. So I-Squared means interdisciplinary and integrated. So in this program we have 20 seats, but really competitive 20 seats I would say, and we have currently 4 batches running on. So we have 80 BSMS students, and we have also initiated PhD program in our department from 2024, and currently our PhD student is 28. So if I give a brief overview of our program, that why it is different from the all the other IITs and other ISERs, what is the extra thing in our ISER TVM School of Data Science curriculum. So we mainly believe that a data science can be made if they have strong foundation in these 3 baskets. So math, stat, computer science and AI/ML. So we mainly focus a well-balanced course structure we have done, focusing on these 3 baskets, and that is actually distributed over the full 8 semester, from semester 3 to 10. It is well distributed, and we have the option of doing project at the last year in the 5th year, and we encourage our students to do collaborate with the other academia or other industry related research to do their 5th year research. And apart from that, we also provide 8 electives and 2 open electives throughout this structure, and we have a bucket of electives as well, where they can do lots of electives. We offer them offline and online, so that they can keep up with the recent advancement of AI related or data science related courses they can take up. And from open electives, since we are a basic science institute, they can choose some open elective which they are liking, some course in physics, chemistry or maths or somewhere. So open electives we also provide. And for here I like to mention that we also for PhD here, since we have external students, college students, I know some few of you have some research dream to pursue research. So we offer 2 direct route for PhD. Every year we got 2 calls. One during one call advertisement come around April, another come around October. So you can follow our institute website for further details. And also if you have your own fellowship, like UGC NET or Inspire or some other fellowship, you can in the year anytime you can contact the school and you can join immediately. So there will be no delay if you have your own fellowship. So next, since I am talking about PhD, we should talk about the research theme in our school. So we have 10 faculty, but 10 have different research area. So in this from this 3 basket, we have from probability statistics we have research persons who are working in clinical trials, cluster randomized trial, longitudinal study. We have persons who have doing research in survival analysis, reliability theory, comparison of statistical comparison of populations. Then we have in theoretical computer science we have algorithms, graph theory. Then communications network related, we have faculties who work in communication area, 5G in a 6G network, and then cloud computing, edge computing, fog computing. Then in the artificial intelligence area, we have faculty who are experts in deep learning, then data privacy, synthetic data generation, distributed deep learning models. Then computer vision area, we have more than I think 2-3 faculty who are working on image processing, medical imaging, quantitative imaging. So this is the overview of our School of Data Science research team. If I say in a nutshell, these are the highlights of the research is currently happening in School of Data Science. So obviously for research we are, since it is a data science department, we have to collaborate. So the faculty is currently collaborating in various fields. So like various hospitals like Chitra, KIMS, CNC Vellore, to ISRO, ASAP Government of Kerala, Kerala Puris, IIC Art Park. So these are the academic on the various healthcare related MOU and collaboration currently we are doing. Also we are doing some collaboration with industry as well. So these are our industry collaborators. So faculties, although we recently got to the number 10 faculty, but our publications and other contribution to the field of research is, I would say, well balanced. And we have among our faculty members, we have senior members of IEEE, INAE, senior members. Our faculties work as associate editor in various reputed SCI journals. And currently in the department, 11 ongoing project is happening worth of more than 5.7 crores. Students are also doing really good job in our department. They are also publishing research papers in conference, in journals. They are so recently we have our first batch graduated from there. The first and second day went for research. One went to University of Turin, Italy. One went to the University of Texas, and we got placement in industry as well in Allianz Finance Group, and another got in Mavenir. So also our students got various fellowships like DAD, Infosys Foundations, Inspire. We have many scholar students in our department, and also due to the curriculum, I said well balanced. So most of our students actually qualify GATE in their fourth. When they are going to fourth year, they are able to crack the GATE exam. So the school is also actively working in various to make our students engage and to make them familiar with various current events that happening in the data science field. So we are doing research talks. We are doing placement, making our student placement ready with the placement training sessions. We are doing industry connect sessions. We are calling UBE. We are calling RBI persons. We are calling from Google. So many already come and visit our campus. And also this year, one school initiated one online course with the collaboration with ASAP Government of Kerala, a 8-week online course on advanced data science that will be offered. And also, I like to mention to the external student, every year annually we do a frontier series where we select 25 external students to come and visit, participate in this conference. It's a 2.5-day conference. So we just did it in last weekend. This is our third year, so I will invite the external students to really see our website. So this is a very interesting symposium that's happened, which give you the idea what is happening currently in AI or in statistical machine learning, or what is the current research is happening in the industry. So this is all I would say we are doing, and we are planning to do more to make this school active. So next I would like to, I know I talked much, but now I would like to say one word, a few words, that this event is only possible because of the generous support of our director, Professor J.N. Murthy, and today's event idea was actually came up from Professor Anil Shazi sir, who is our past HOD and who is like a umbrella, who is still an advisor in our department. So he actually gave this idea to have a event like this, a industry and academia kind of AI kind of event in this campus, because till now nothing happened this kind of event till now. So I really thank him, both of them. So let's give a round of applause, and please I would like to welcome J.N. Murthy for coming on this.
Very good morning, and thank you, Dr. Priyanka, and a warm welcome to the visitors who are going to be the speakers for today. Yeah, I think I would like to acknowledge upfront the efforts by Dr. Anish Raji, who has been really mentoring this particular new department which we founded in 2020. And I have no hesitation in saying that this department has really shaped up with time in the last 5 years, and one could see the kind of transformation, starting off with no faculty, having one in 2022, rising in terms of the strength to about 10. And vibrancy, I love this, right? We have chemical sciences, physical sciences, biology, but in spite of the fact that the school is so in its infancy, being in its infancy, yet on a Saturday, to see the enthusiasm of the faculty themselves, present, everybody, and the students that are part of the data science really taking part with no delay whatsoever on a Saturday. It's quite heartening. And clearly, going by what Priyanka madam put out for us, dished out for us about the growth of the department and the products, it's really pleasing, right? I think the students are, the first batch that graduated has really gone on to pursue higher studies, some choosing to work in industries, reflects in itself the growth aspect of this particular school. That said, I think today's program, I would say, has been spearheaded by, I think, Professor Shaji, who continues to not lose his grip on the department for whatever reason, right? He has mentored, but I think his mentoring continues and should continue. I think he's one who contributes not only to the department, to the institution in a big way. He's been contributing in a big way. Priyanka has taken over the reins of School of Data Sciences. She is young and still an assistant professor, but I think the dynamism is abundant in her. And you can see the way that she speaks, it brings that energy into the department. That said, let's come to the theme of today's getting together. The reason for us to getting together, the AI. I think you should switch off all your cell phones. Maybe you should not be, need not tell you this. Some conduct that is expected of you. Okay. Yeah, I just was in Delhi for some kind of a big meeting just a couple of weeks back. I think there is a big think tank which worries about the directions in which our country should be kind of progressing with absolutely no induction whatsoever, and I would say induction period. AI has become very transformative, absolutely disruptive, we all know. It's transforming the way that we live. We all have seen the robots and stuff like that, but I think the way it is invading into our lives is simply unimaginable. In every sector, be it a climate change, or be it energy, or be it pharmaceuticals, be it anything that you talk about, even for the societal benefit, even our own lives. I think about basically the vehicles being auto-driven. I think they're already put into use. And even the ones that you buy today, the vehicles that you buy come with basically kind of artificial intelligence, AI, installed, pre-installed, which kind of guide you in a risk-free manner everywhere. Right? So where do you want to kind of look at and say, yeah, here AI is not possible? I think, chemical sciences, this was our really vision in 2020 when we started. Yeah, business sector and manufacturing sector will worry about AI, but the science has to be developed. Fundamental science, right? Maybe the AI will invade, and we should have basically data sciences in our institution. Data sciences more focused towards scientific research was our vision. And can you believe it, in 2024, right, that we had this DeepMind, Google, kind of cracking the problem of predicting the protein structures with GPT models. I've been asked to give some talks here and there on the Nobel Prize. I just gave one the other day for the resonance, and one I'm going to give elsewhere. I was just looking at the literature on metal organic framework structures, materials, And this Yagi, who got the Nobel Prize just for 2025, he has been basically the crucial man, pivotal man, contributions to the development of metal organic frameworks, materials with open spaces. What do you do with them? And one of the simplest application is, how can you basically kind of generate water in a desert by plucking basically kind of water molecules that you have in the air, moisture, even at humidity levels of 20%. That is what basically triggered award of the Nobel Prize for the development of materials. And in the recent 2023-24 paper in Science and Nature, I don't recall, he has published this paper on AI for improving the materials properties with better efficiencies for capturing the moisture from the air with GPT models. This is absolutely application of the AI for sciences. This is exactly what the top think tank in the country is really worried about. Are we going to be left behind in the country when in a very few years this is going to change the world the way that we see, in the way that we cannot recognize, right? And we had this, all the directors basically were told that we cannot be kind of, held back in this transformative science. And I'm soon there is going to be a kind of a directive to all the institutional heads to bring in AI at the foundational level. Start teaching the students, start training even the advanced teachers. Right? None can say no, AI is not applicable to me. Right? When I initiated my research in 25 years back, we were using the transparency sheets for presentation like this. I'm sure the very eminent radiologist in the city who was a practicing doctor here. The other day I had an invitation from him. I just wanted to check on who he is. I was shocked myself. He's publishing probably some of the scientists don't have here the kind of citations and the publications that he is making. He's still a practitioner. We have such an eminent person here. I was really pleasantly, pleased to learn that he uses AI, and in fact, he is going to give a talk here, data science protocols, on this particular one. What I'm saying is that AI has become so much, and more so in an institution like ours. I think we are the ones who should be basically teaching this to the students who become the next generation leaders. If our country has to advance and push pushed in this frontier, this has to be through you guys, the student community, and the teachers, the faculty. Yeah, those that are in the profession, of course, anyway, regardless, pick up, but then people like me cannot pick up. That's the point that I was trying to say. In our generation, basically, we were using the transparency shades. Come to 2002, 2003, we had this PPT. And trust me, up until 2007, 2008, some senior to me were reluctant to use PPT because they were used to using the transparencies. But when this was extended to us, then the problem was, in fact, I became a fool myself, using all kinds of colors that are in the palette, yellow and green with letters that don't show up when you project. You improvise with time. Then you realize that a white background, you need to have dark color. You become better and better and better and better. And today, the slides are anybody who makes have some kind of a feel for it. The resistance to change is something that holds us back, right? And this is where, in fact, the emphasis to some of us was that AI should be learned by one and all, regardless of the age. And get into any website, and there are these basically advertisements. You don't need to be afraid, and you don't need to be held back because your age is so and so. It's all, anybody can learn AI in a few lectures, 15 or 20 lectures. That's how the advertisements are. I think the time is up, even for me and people like me and the like, to pick up a little bit about AI and to ensure that we keep ourselves abreast of the developments in this particular area. So from that point of view, I think this is AI for science. Ours is a science institution. We are going to definitely take up academic curricular revision to ensure that AI is AI is introduced right from the year 1 for your BSMS program. And accordingly, we kind of bring in the experts. We already have in-house resource, but if there is something missing, and there will be emphasis on this. I think from that point of view, this kind of lectures, workshops should be seen. I think it's a beautiful opportunity for you to listen to the practicing scientists and be informed citizens being as part of the data science, because the guys in chemistry and physics probably don't get this, right? So unique opportunity. I think the data science should be really leading us and teaching even the faculty around that who are still not very open to learning AI. I think we should enthuse the entire community and push the community along the direction in which the AI is really taking the country and world as a whole, right? With that, we have 3 eminent people here. I think Professor Mishra, IIST, is a well-known face to us, and I'm told that the professor from Sri Chitra has been here earlier for the Frontier Symposium, and we also have a very young dynamic scientist from Adobe, and I'm sure with 1 or 2 more lectures from our in-house, the day will be a really glorious one, and I'm sure the students and the outsiders will certainly take home an enriching experience. All the very best. Thank you.
Thank you, sir. Now our official session will start. So first, I would like to invite our data science faculty, Dr. Saptarshi Beje, to introduce the research and machine learning for science. Please.
Thank you, Alvin, for the platform. So in the beginning, we are just going to give some brief short talks just to introduce the research of our department to our guests and all the students also. So I will be just taking 10 minutes to talk about the work that is going on in my group, and more specifically, I would like to emphasize that how science inspired my machine learning, right? My group is called IDEA. The full name is Intelligent Data Enrichment and Analysis. So I need to make this font a little bigger. I realize now. Yes? Okay, great. How to change the slides? I think I can manage with this. Okay, so first I will talk about machine learning inspired from physics. So I was actually watching a documentary on gravity, the mystery of gravity, and I ended up actually writing an algorithm on it. So I will just tell you how it is, how that story was. So what we understand is that in the space we have in some places we have masses, and where there is more mass, there is more gravity, right? And things actually gravitate towards mass, right? So more mass, like in the center of every galaxy there is supermassive black hole. Most galaxies there is supermassive black holes, and with time, stars and all gravitate towards that black hole, right? So what if we can think of the same thing for data spaces? We know that just like our space, data also resides in a space of probabilities, right? And where there is if you pick up a random data, it comes from a probability distribution, and at some places there is more mass, probability mass, and in some places it is sparse, right? So in the same way that gravity works, what if we can gravitate the data points towards places of more mass, right? So just like a gravitational field, but of course, in case of data spaces, it's a probability field, right? Probability density field, right? So I just tried to write a function, write an algorithm based on this idea. And the idea was that if we have a data space, high dimensional data space, I will try to gravitate all the data points towards, where there is more and more density, and that will, even if the data is high dimensional, it should be able to reveal clusters in the high dimensional space, right? So you have all, our students probably have all learned about these techniques. So one of the basic techniques we know is the mean shift clustering, mean shift algorithm, right? So what mean shift algorithm does is exactly this, that it gravitates data points towards higher density regions, right? And the problem with that is that when the data, and how do we actually model density in that case? We model it using something called, so if the probability density is not known, we usually model it using something called the kernel density estimator, right? We take up small probability densities around data points, and we add them up, right? And then it gives us an estimation about the density, right? So the problem with this approach is that this is computationally not very feasible. If you have very high dimensional data, and if you try to do the same thing, it will fail. It is not scalable on very high data sets. So we developed some techniques to actually make that feasible, right? So here you can see it's all it's actually the PCA of our favorite data, which is the MNIST data, right? And you can look at the PCA. So this is the two-dimensional version of about a 700-dimensional data. And what it does in the next pictures.
Put that in your pocket. So give the pointer. One should be in hand, the other one should be.
Yes. Okay. So what we see here is that after the algorithm is run for different parameters, you can see that you can see that the points are gravitating towards denser and denser regions, right? So one idea, then I was thinking that where we can apply this. So one idea that came to my mind is that we can apply this for anomaly detection. If you think of Pluto is an exoplanet, right? So, or comets, they are exoplanets. So they are sort of outliers, right, in our solar system, right? And everything is rotating around the sun. So one day these outliers will also come into the gravitational field of the sun, and most probably will bump into the sun. But we can actually see that Pluto will take a long time to actually bump into the sun, and Earth will probably take much lesser time. And that means that we can detect outliers by gravitating points towards more density and finding that which points actually traveled more distance, right? In that sense, so this is this gravitational field changing that I was talking about. In that sense, what I did is that I just tested it on the MNIST dataset as well, and we see that these are the handwritten digits that have minimum shift, right? So we are gravitating the points towards higher density, and these points have minimum shift, and you can see that they are just normal handwriting, right? These are normal handwriting, and these are the points with maximum shift, and you can see that these are anomalous handwriting. So these are the digits are written, but they are not clearly visible, right? So that sort of confirmed my hypothesis for the first time, and then I tested it on several algorithms, several data sets, right? And found out that it really works quite nicely compared to several unsupervised algorithms. It is performing quite well, right, among the top few algorithms. So yeah, so actually research generated from basically a thought in science, right, a science documentary. So this is how maybe science actually inspired me to come up with this project. And the second project is also, so here the algorithm is not inspired, but the problem is actually inspired from biology, right? So what happens in biology is that you have protein networks, right? So proteins interact in our body in several ways, but what happens is that the wiring of the networks, right? The interactions change as per contexts, right? We have thousands of proteins, around 20,000 proteins, working proteins in our body, and their interaction changes based on contexts, right? If you take different cell lines, the wiring of the protein networks are different in different cell lines. Now, if I want to understand whether a drug works. It might be so that a drug works in one cell line but does not work in another cell line, right? And if we want to understand that, if we want to make a predictive model that can say that, okay, this drug works in this cell line, will it work in some other cell line? So then, to make this kind of models, we need cell line specific embeddings of nodes or the proteins, right? We have to understand cell line specific embeddings of these molecules, right? Since the protein interaction networks are huge, so we have to learn these embeddings very fast, right? So inspired by that problem, we also created another algorithm which is called this fast node embedding learning. So if you have huge networks of the order of millions, like 20 millions or something, so this works also in semi-supervised and unsupervised scenario. You can learn in different contexts. You can learn protein or you can say graph embeddings or node embeddings in graphs. And you can see that you can learn the actual patterns here. The clusters are also learned. That is actually clear from these images. So this algorithm is called Fuse. I mean, just to give you a number, the data set, which is sort of one of the best benchmark data sets, is called the products data set. It has about 20 million nodes, and our algorithm runs in about 2.5 hours in this data set. And the nearest algorithm that does the same job takes about 40 hours to run. So if you have multiple contexts, then our algorithm would be way faster in generating the embeddings, right? So this is another problem that we worked on. So it basically, that if I don't want to go into the technicalities, but it basically leverages on something called graph modularity. And the way it works fast is because we have used an approximate gradient of the modularity function, which actually aligns well. If you measure the cosine distance between the original modularity gradient and the approximated modularity gradient, you will find that both of them point towards similar directions for graphs with a limited amount of sparsity. So let's just limit it to that. So these are just two problems. We have more problems that we are working on in our group, which are also inspired by science, but I will limit my talk to only these two problems. Thank you.
So it's a really good start for AI for science, really interesting start. So next, I will call another faculty, Dr. Alvin Paulos, to share AI for science, what's happening in their lab.
Yeah, I do.
Thank you. So it's my pleasure to introduce my research to a community. They are so curious about data science and the research aspects of what's happening in my group. So the group name is like Deep Intelligence Learning Lab. Normally we call it the DIL Lab. So here we have some mission. Like when we started this, we made some mission like to address, like mainly explore or innovate and push the boundaries of deep learning research and its application. So we're trying to understand the underlying principle of neural network, develop cutting edge algorithms, then leverage the power of artificial intelligence to solve some complex problem across diverse domain. So that's one thing, and also we have the vision to be a leading a global leader in advancing the frontier of deep learning, shaping the future of artificial intelligence, and fostering positive societal changes. So these are some of the key idea we follow in our lab. So the core domain, the entire our lab, we stick into one point, that is human behavior analysis. Then different perspective of human behavior we will analyze. So first we do with the affective and cognitive behavior. So mainly the students, they do some other points like stress detection, then depression or anxiety prediction, then similar cognitive load, then similar like distraction, then various application where you can apply these points. That's the one thing. And the other one, visual behavior analysis. So here mainly we focus on the human emotion in the perspective of like facial images. So we consider the facial emotion recognition, then like facial action unit. What do you mean by facial action units? Like some muscles from your faces. Then we, based on that, we identify what type of emotions you carry. Then similar human pose estimation, like as part of your entire body posture, we analyze, we estimate the posture, and based on that, we analyze the behavior. Then similar gaze tracking, eye tracking. These are like some of the other components. Normally we understand how the behavior can be connected. Then similar speech and audio, that is also another component. We work on that. Some of the work we do with the speech emotion recognition. So we have the speech signals, then we do some processing, and based on that we identify what type of emotions like the speaker is carrying. So based on that we do some analysis and studies. Then activity and motion behavior, that is another area. Here mainly we consider like the human behavior, human activity recognition, then abnormal activities, then fault detection. So like very innovative research these days, like when the parents or the old people in your home, then most of things like their kids or their son or daughter, they are not in the home. So they normally keep a camera and they monitor like how, if it is a very old people, it is our responsibility to monitor. So we do this type of monitoring to see everything okay or fine. So that's another very hot research, I can say. Then similar tracking and spatial temporal behavior. Mainly here we do the human tracking. So human tracking, basically we do the location, like identify the location. We already know global positioning system is very active. You always use your Google map. But when it comes to inside a building, if suppose we are in the PSB seminar room, how do we track or how do you identify your position? Then like an indoor scenario, the global positioning system will not work, the GPS signal cannot be penetrated. So in that scenario we have to think about some ideas how to track the human. Then trajectory analysis, that is also another area of interest. We work with like the pattern of the movement. Based on that we will study like what type of some way connect with some behavior analysis. Then social and interactive, these are like our long-term goal. Currently not getting to in the human perspective, but as part of interdisciplinary research, we do in animals like social interaction, like the zebrafish. Next slide, I will explain about the interdisciplinary research, what is happening in my lab. So here, social interaction in animals we studied, but also in the future long-term goal, we have the plan like the social interaction and also group behavior analysis. Then similar leadership and dominance detection. So last year minor project also one student was doing in the leadership, but it was in the animals, not in the human. But in the long time we have the plan like think about the social and interactive behavior. Then clinical health behavior, pain detection. So that is also very interesting topic we will consider in the future. Then sleep behavior analysis, that is also currently if you see your smartwatches, they will give the quality or some measurement how good was your sleep. So that is also very important to analyze your health. So that is also another parameter or research. Then some contestant aware and digital behavior is like smartphone use behavior. That is like very relevant. I can share from my experience when I teach these days. The student use their phone and ChatGPT and they ask questions. So it's like very challenging for us. Or it's like this type of, but we cannot say we cannot use the smartphone because attendance we are taking using smartphone, so we cannot block that one. But the smartphone usage behavior, that is like, so now it's like very challenging for us, like in the teaching perspective, like how this behavior is like affecting the human context. And also wearable sensor behavior is like, I can give an example. If you use smartwatches, then you set a target like per day 10,000 steps. So you are so curious, or you always think about that, today did I reach 10,000 steps? like always carrying that anxiety, like I should take 10,000 steps today. That is give some changes in your behavior. Of course, that will be added. So that is like another factor. Similar, same one more multimodal analysis, like comparing different concepts like vision and audio. Then physiological signal also. Physiological signal, here we consider EEG signal or the heartbeat or ECG signal. Some of this signal, physiological signal also, you can consider for your behavior analysis. And some emergent and advanced topic that is also in our future goal, like ethical consideration of human behavior. Then similar, this cross-cultural behavior, then explainable behavior AI. These are the some topic we summarize in the long-time goal. We can study these factors. So this is the overall like a core domain research. But of course, we are not working all this topic. Like some of the topics like actively working, and these are like some expansion in the future we plan to do. Then as a ISER, I got the opportunity to expand or introduce the idea into interdisciplinary or the other domain. So first 2023-24, we started work with Dr. Amrita Swaminathan, School of Biology, and mainly zebrafish anxiety prediction. That was the one core component. There we analyze the social behavior characteristics, leadership characteristics, like we put a group of fishes together. Then from that we analyze like is there any leadership, any fishes showing any leadership quality or leadership behavior. Then similar, some fishes are following that one. So that type of studies we did. Still the work is going on as part of minor project. Then analytical chemistry, I had a student from School of Chemistry, and we worked with the pesticide detection. So that is also one work 2024-2025 we did, mainly introduce the concept of AI, then understand the pesticide detection in a very minute level. Then similar cell biology, like we started recently some works with the Dr. Nishana with the age classification considering the circular DNA. Then similar Professor S. Murthy Srinivasa, that we started like I think 2023 onwards. The work mainly analyzing the Golgi body dispersion. Then introduce the concept of machine learning and automate this process. Then recently we started with the Professor Tapas K. Manya, like analyzing the primary cilia morphological characteristics. They have their own research problem. So like as part of minor project work, we do that one. Then last year also we did atmospheric science, some work with the Dr. Anand, School of EESS. So here we did some modeling of atmospheric optical turbulence with the help of some deep learning architecture. That is also we did. Then astrophysics also, some students are approaching with the problem. So this is also in the initial stages. These all are part of minor project we are considering or we are applying this AI in the science. So here prediction of supernova, then solar flare classification. Then the another interesting topic is like sunspot rotation, how this will be affecting the coronal temperature. So that is also we are considering. Then plant science, also the stress in the even human we can analyze the stress. Similar, we study about what will happen if you apply stress to a plants. Then the characteristics of plants, how it will change. So some way we connect with that one with the Dr. Anirban Guha. Then similar medical AI, we work with some international collaboration, like the growth of cervical vertebral maturation. So that mainly identify the human growth. Then similar last in AI agriculture, we do some works with the pest detection using computer vision. So this is the overall interdisciplinary. I just want to show like the concept of data science is like widespread. So you can apply the concept wherever the tool is needed. So you can consider as the tool, and whatever the algorithms or whatever the concept you study, you can easily apply into the core domain, science domains. That's we still doing, and it's successful, I can say from my experience. So there are like wide opportunity as a part of interdisciplinary. So out of that, like I took very time's over. Yeah. So very 2 minutes, 1 second. So out of that, like very few works like EEG based emotion, then some speech based work, speech based emotion recognition, then depression detection. That is also one work we did. Then some also we work with some real-time implementation like identifying the facial landmarks. This is mainly used for driver distraction identification and also hand guest recognition. That was also part of another work like in a real time. Then similar here human pose estimation. This is also in the real time we tested. Then here also another work my student did like a deep fake detection. So here you just upload an image and our system will identify the image is real or edited or AI generated image. So that is also another. So here you can say it's like predicted as a fake image. So that is also another interesting work we did our lab. So that's all. Thank you.
So if so due to this we are running a little late, so we are skipping the Q&A. But this all the our faculties will be available during tea break and lunch. So if anyone of you have any question and answer, I mean questions or any doubts, you can interact with them. In fact, you can visit their lab also. So next I am calling our faculty, Dr. Raju Susan Matthew.
Good morning everyone. I will be talking about artificial intelligence in computational biomedical imaging. So as the name suggests, we work on medical imaging. So medical imaging enables the visualization of lesions or diseases within the body. So as shown here, you can see that it consists of the acquisition phase where the scanning is performed and raw data is collected. And once the raw data is collected, we have to perform some algorithms to recover the image, which we call as reconstruction. And once we obtain the reconstructed images, we have image-based tasks which involves detection, characterization, monitoring, etc. to understand what are the abnormalities present. And based on the images, the clinician will prepare the reports. So we typically work on different aspects of medical imaging. One of the most important aspects which we are working on is quantitative imaging. So compared to qualitative imaging, the difference is that in quantitative imaging, each voxel will have some inherent meaning which is related to the tissue which is underlying. It is not just some value, this value will have some property of the underlying tissue. So in quantitative susceptibility mapping, we look at the susceptibility values of the tissues, that is how much the material gets magnetized when it is in the presence of an external magnetic field. So here we measure the susceptibility values with respect to water. So if the values are lesser than that of water, susceptibility value is lesser than water, then it appears as hypointense, and if it is higher than water, it appears as hyperintense. So one of the most important advantage of QSM is that it offers excellent contrast between iron and calcium. So it is more evident in the second image. You can see that this is a CT image and this is an MR image, which is T2 star weighted, and this is the QSM. And if you look at this, there is an abnormality which is hyperintense, and this is hypointense here. But you can see that in the QSM, it has hyperintense and hypointense regions, which indicates the presence of iron and calcium. So this hypointense corresponds to the calcium, whereas hyperintense corresponds to the blood deposits. So both of them are evident in the QSM. So that is the important advantage of QSM. So having said that, getting the QSM is not that trivial. There are multiple steps to be done to obtain the QSM, which involves getting the phase from the MR image, then phase unwrapping, background field removal, and dipole deconvolution. So which is related by this linear equation. So we typically work on the deconvolution step, wherein we obtain QSM maps from the local field. So there are multiple methods to reconstruct the QSM. So there are single orientation methods. Single orientation methods means we acquire data only in one orientation with respect to the main magnetic field. But in multi-orientation methods, we acquire data in multiple orientations with respect to the main magnetic field. But this is not practical in the clinical setup, as the patient has to lie in many orientations and some of them may be unnatural. So we focus on single orientation methods for the clinical practices, and there are conventional methods and deep learning based methods. And so there are different types of methods under each of these categories, and these blue methods are our own methods. And multi-orientation methods, there is the Cosmos, which is the gold standard for the QSM, which we use for comparison in the volunteer studies. So this is one of the recent article which is based on one of the recent article which is published in NMR in Biomedicine. So here we used model based deep learning. So we have already the physics relation which connects the local field and the susceptibility map. So using that physics along with the CNNs, we have this iteration specific denoiser. So previously we have model based deep learning methods which uses data consistency, which is the physics relation, as well as the CNNs in the denoiser. Here we use specific denoisers for each of the iterations. So that is the difference, and we have seen that it offers better generalizability compared to the pre-existing methods. So these are the reconstructed susceptibility map at different iterations, and the HTN values are shown here, which shows the errors in the high frequency regions, which are the errors. So this is one of the recent work which we are doing in our lab by one of the BSMS students. So we are looking at the interpretability of the QSM reconstruction. So for the previous methods, we know that how we are actually obtaining the QSM. We know what is happening to each pixel. But most of the AI based methods, we don't know what is happening inside the AI model. It acts as a black box. So can we come up with some interpretability? What is happening to each pixel inside the AI model before actually obtaining the QSM map? So we are able to understand this. So we have an action map which tells us what is happening to each pixel. We have defined some filters which are used for this, and we can see what filter is applied to which location, and we can understand what is happening to the each pixel from the input, which is the TKD susceptibility map, to the which is a conventional method, to the reconstructed susceptibility map. So we have also seen that this can all equally perform well in terms of generalizability compared to the model based methods. Apart from this, we are also working on the clinical application of QSM. So QSM is also used to obtain the oxygen extraction fraction. Oxygen extraction fraction tells us how much oxygen is deficient in a particular tissue. For example, in the brain, we can see that this red regions will have deficient. It is deficient of oxygen. It has deficiency in the oxygen. So can we obtain OEF maps using QSM? So for obtaining the OEF, the actual gold standard is PET. But we cannot perform PET always because of the radiation as well as the unavailability of PET scanners in the hospitals. So we are working in collaboration with SAT-IMST to obtain task-specified, task-optimized QSM. That means for this particular task, we are optimizing the QSM, and can we get better interpretations for the oxygen extraction fraction. So I will also rush through one of the other important work which is happening in our lab, which is the median nerve segmentation in ultrasonography. So here we are actually finding out the area of the median nerve which travels from the hand. So we studied from the wrist to the elbow. So can we find out, can we delineate the exact boundary of the median nerve when we are traversing from the wrist to the elbow? So we have collected the data here. We acquired ultrasound data of 100 patients. Each patient has 300 frames. So approximately 30,000 frames we have, and we got the annotation from the clinician, and we had different AI based models. We have tried with different models. Just a unit based model is shown here, and we have compared with the clinician's annotations how our predictions are. So this is one example with our model. So this is the unit based model, and this is the new model which was developed, and we can see that this red one is the prediction and the green one is the actual ground truth. We cannot say ground truth with the annotation by the clinician. So here we have seen that with the use of our model, the predictions are better, particularly towards the regions where it is farther from the wrist. So this is one other work, and this is the clinical setup which we have implemented in the hospital. So this is the ultrasound machine, and this is the monitor wherein we can see the prediction using the laptop, and there's a frame grabber which just passes the input from the ultrasound machine to the laptop. So with this, I am just concluding our research. We are working on some more aspects of medical imaging, but in the interest of time, we are concluding. So these are the acknowledgements. Thank you.
Thank you, Dr. Raji. And next, I invite Dr. Sakriya for his introduction about what he is doing at ISAP TV.
Hello, can you hear me in the back? So hello everyone, thanks for coming once again. My name is Zakaria Daskar and I am an assistant professor here at the School of Data Science. My primary area of research is 3D computer vision, where we are interested in not audible, okay. Better? Yes? So I work primarily in the area of computer vision, where we are interested in understanding images captured from the 3D world. We primarily work in the intersection of computer vision with machine learning and applied algebra advancements in multi-view geometry. I'll show some examples which we typically research in this particular area of intersection. In addition, we also try to challenge existing methods by constructing new data sets to push the state of the art. Here we are interested in constructing new data sets, but also benchmarking how these methods are performing on this new data set, and then also trying to accelerate the process of annotating this data set. So one of the main interesting challenges in our group is constructing the 3D world back from the 2D images. So the real world is usually 3D, but we capture this 3D world in the form of 2D images. But now we're trying to solve the inverse problem, that given these 2D images, we want to recreate back the 3D world. The second challenge is, once we have the 3D world, of what use is it? One of the main use cases is to assist a robot to navigate this 3D world, for which it needs to understand where exactly is it in this 3D map. This is similar to GPS that we use in our Google Maps, but it's a 3D problem now, not the 2D problem that not the 2D solution we have on our phones. This can also be used to create a digital version of the 3D world. So this is a street outside IIIT Hyderabad, and this is a 3D digital twin of this of the real 3D world. And this we can then a user can use some kind of simulator to navigate this scene. We can even use to train drivers and also autonomous agents, like the autonomous vehicles, to drive in real streets, but in the digital version of the real streets. We are also interested in motion modeling of humans, where given some input images of the person, we can create the 3D model, but also learning how to animate this 3D model. Also, objects on the road. For example, here we have a lot of traffic, and we create this 3D model, but also how the 3D model moves in the 3D space. This we intend to use for traffic management. Once we model how objects move on the road, we can offer suggestions how to improve the traffic scenario in very busy junctions. And also, so in the previous two cases, we had humans and objects separately, but here we are looking at them jointly, how humans interact with objects. For example, here we have just a 2D picture of a person holding a chair, but here what we have done is created this 3D model, which we can then view from different angles. This information was not present in this input image. But once we have done this inverse rendering, inverse mapping, we are then able to see how the person looks and how the human-object interaction looks from different viewpoints. Apart from this, methods and applications, we also work on data sets, as I mentioned earlier. For example, here one of the data sets is collecting objects which are not supposed to be on the road, for example, dogs. So typically in Western roads, we don't have such scenarios, so people are not able to study this problem adequately. So what they do is they synthetically place some objects on a very empty road. But this is very unrealistic. But we have, in our Indian context, this setting is very common. For example, we have animals, we have some random electric wires or construction materials on or near the road, which are not supposed to be on the road. So the objective is to challenge the existing models if they are able to detect these kind of obstacles on the road. So our Indian roads provide a natural data set and benchmark to test these algorithms. And to annotate this, this data set, for example, here, an annotator has to come and annotate each pixel to the corresponding object. For example, here it should say that this pixel is a road, that particular pixel is a car, the corresponding pixels are trees or roads. So it takes a lot of time and cost. So usually the whole annotation process involves humans all the way. So what we try to do is accelerate this process using some advancements in machine learning so that we can put algorithms instead of humans to do, let's say, 30 to 40% of the task, which results in a lot of decrease in the annotation cost. And something very interesting we started recently to see how these GPT kind of models help us in generating videos that can be used to teach physics concepts to children and to general public. So what we have here is, let's say we want to create some video of Newton's first law of motion, and then we try to benchmark how these models perform. So our key finding is, if you just give this particular line as an input to GPT or this state-of-the-art video generation model, it doesn't create very good quality videos. But if we are able to break the concept down into sub-concepts, the way we also do while teaching, then it does pretty good job of generating plausible videos, not very high quality like the way we want, but still it is right up there, like GPT-4 models, GPT-5 models. That's pretty much it. Thanks for listening. You can chat in the feedback if someone is interested.
Thank you, Dr. Sakaria. So now we will go for a 10 minutes tea break. After that, we can start. Then during break, you can interact with the faculties, especially the external students. You can interact with the faculties and discuss about the research opportunity at ISA TVM. Thank you.
Mic, only mic off. That first one. അഞ്ചെണ്ണം
And also there is a now unified umbrella. We have nothing more
Yeah, I know. She told me last. I didn't know.
We'll continue with the research overview from our faculty. So now we'll welcome Dr. Suresh Chauhan. Please give a round of applause for him.
Thank you, Supriya. Good morning, everyone. Welcome back. I am heading the SPIN lab, Sensing, Perception, Intelligence and Networking lab. Main focus of the lab is to provide the safety, security and the reliability perspective to the vehicular communication. So today I would like to talk on very briefly artificial intelligence for mobility. So we all know the mobility, right? The movement, moving from one location to the other location. So in our day-to-day life, we are using this, and this mobility has become the backbone of the modern society, correct? And whatever the current transportation system we are having, so that is not the safe, right? It's not safe, it's not secure, and it is an inefficient transportation system. So in general, we can say that the transportation system, the current transportation system is a reactive rather than the proactive. So after the occurrence of the event only, we will be going to react, right? So that's why our AI will come into picture. So how the AI will change the current transportation system. So that's about I'll be talking. So let us understand the few problems. So we have seen like this road accidents, right? And you can see the overspeeding the bike, right? And the potholes, right? So in these two cases, we can see what is going on, right? Even driver can see what is there. Still we make the mistakes. And here in this case, these are the potholes we cannot see, especially in the adverse weather conditions, right? So the common characteristics in all these three, and many more problems are there, is the lack of awareness right? The whatever it is happening surrounding, so that is not known to these vehicles. That is the one. Another one is they are not coordinating with each other. That is the another one, right? So and these vehicles, right, and the bike, so these are not intelligent. So according to the statistics, so in the India, approximately 5 lakh accidents are happening per year. Okay, and out of 5 lakhs, around 1.6 to 1.7 people are dying. Okay, so roughly 20 people will die due to the accident per hour, and for every minute, 1 people is going to meet with the accident. So with this brief introduction about the problems, so how the AI will provide the solutions for all these problems. So the AI will enable the whatever the entities are there in the transportation systems. So you can see the vehicles, you can see the infrastructures, the pedestrians who carries the mobile phone. So we need to collect all those data, right, and run our AI models wherever it is possible. So to be specific, we will run these AI models on the device, on the vehicle, on the edge devices, right? As well as when we say the complete city, then we can run on the cloud if you want to know what is happening in the entire city. So I want to know that. So after a 5 minutes, right, what is the traffic congestion at a particular junction? Right? So for that reason, we can use some of the models, the AI models which are available. So my lab works on this area. So we try to provide the solutions for whatever the problems we have seen in a previous slide. Okay, and one more problem here is the traffic signal control. So whatever the traffic signal we are having currently, those are the traditional. Like we have the fixed time, right? So 120 to 150 seconds in Bangalore if you consider, and Delhi if you consider 150 to 200 seconds is the actual, right? So without considering the current context, so this waiting time period will be there at the intersections. So what if we provide with respect to the density based control, right? So such solutions we will be focusing on our lab. And now I will be going through our ISER TVM campus, where we have simulated the entire campus with the vehicles. So we try to whatever the behavior we see in our in and around the situation, right? So those behaviors we will try to simulate it in the Sumo. So this is a software where we can create the entire structure of the city. So we have simulated only our campus, where the traditional whatever the transportation system is there, only that we have simulated here. Okay. So in this there is no AI involved. So simply they will be running around the campus, right? And in addition to this, we can have our own algorithm to run on top of this. So that is like we should have the interface with the Sumo, and we should have one more software called the NS3, where we can have the communication between the vehicle to vehicle, vehicle to the whatever the traffic signals are there. Okay, so those behavior also we can show in this software. So in addition to that, we have tried simulating something like the parking systems here. Okay, so what if whenever vehicle comes and it will get automatic where exactly the free slot is, and it will come and it will park there. In addition to that, we tried campus bus shuttle simulations in our ISER campus. So this is our shuttle which picks the people from the place, and it will carry out the desired destination wherever it is according to the timetable which we have given to the vehicle. So this is about the complete traditional transportation systems. Now I will be going to show the one model we have, the DQN, deep learning model we have developed for the autonomous vehicles. The autonomous vehicle has a lot of sensors, right? LiDAR, radar, camera sensors, right? so many more sensors are there. So those will try to collect the information, surrounding information, and they will try to communicate with the other vehicles as well as the infrastructure. Can you go to this? Yeah, can you play this? So this is a scenario we created, deep learning based autonomous vehicle navigation. So there we tried develop the TQL to learn themselves, to talk the vehicle to vehicle. Okay. So initially they will be going at the speed of 30 km/h, and when they will come near, so they will automatically adjust the speed. They try to send the information to the other vehicle. Okay. And we can speed adjustment also we can do, as well as we can have the steering control also. Okay. So you can see here the vehicle which is coming here, here, right, and you can see the data which we are gathering. So whatever the data we are gathering here, so we will try to log all this data, right, and we will run it again and again and again. Okay. We try to improve the system. Okay. So once we feel that this is a perfect, then only we will be going to deploy in a real time. Okay. So these are the two vehicles. Again here they will be going to communicate with each other, and they will take the left and right. And the reference point for this, see, whenever they encounter this area, right, so there we don't have the yellow line, so they will get confused. So reference line for them given is this yellow, so they have to detect. So LiDAR will try to detect this yellow line, and they try to be in this line, right. And you can see this is the obstacle detection. So very first time we have done this experiment, that's why it was having some here, something like it's supposed to react at this point rather than here. And we have simulated a few more scenarios, something like this. So vehicle movement without age of information. So whatever the information or the data they are exchanging, right, continuously exchanging, periodic exchange after 5 minutes, not 5 minutes here, after 5 seconds. So which data need to be considered before taking any decision, right? So there will come the freshness of the data. So this is the before scenario was the without age of information, and this was the with age of information. So they will change in a fraction of a seconds. So we cannot see that complete differences here. So like this research work we will be carrying out in our lab. In addition to this, we will do the security related research also, that is the post quantum cryptography for the vehicular communication. Right. So yeah, that's all.
Thank you, Suresh. Last but not the least, we'll welcome Dr. Mainak Adhikari. Please give a round of applause.
Can you hear me? Is it audible now at the last? Okay, fine. So, I am basically establishing a new lab here in Isaac Event. So this lab is, we are saying, the VGNet lab, and the main theme of the lab is mostly the real-time applications. We are mostly working on the edge intelligence and distributed AI for next generation system. So the main target of the current government of India, whatever we are currently focused on, one is basically space mission application, where we are working with the ISRO. That's I am going to discuss. Second one is the 2030, the main goal of government of India is 6G mission. That's we are basically contributing. And third one is different real-time applications with different prototyping we have developed in the real time. And this prototypings you can able to see when you go, if I have the lab, so there are several prototypes already designed. So if you have time, you can come and you can see what are the different prototypes, in real time it is working. So first, so this is the overview of the work. So one is distributed learning, so where we are basically working on the federated learning, gossip learning and federated unlearning concept. Those are the main part of the current 6G missions. Now earlier 5G, 4G, if you can think of these things, those are mostly on the centralized base approach. There is a one centralized base station and all the data has been transmitted to the centralized base station, bandwidth management, security protocol, all are basically mostly centralized. But 6G basically come to the scenario is to make it more distributed. It can mean where the data has been generated, want to process the data locally and try to manage the bandwidth spectrum in the real-time basis by integrating with the AI solutions. So this distributed and 5G, these two things, and we are basically going with the orchestrator development with the CDAC team. So CDAC is now also collaborating with us. We are going to sign a MOU of CDAC Trivandrum. So with that we are making the orchestrator and making all such distributed learning and automation of the networking part in real time. They can help to generate the test bed and all the real-time scenario and protocols. Second one is the basically we are working on basically space-based mission, where is our main target is in the future in 2028 or 2030 there is a several Chandrayaan Mars mission going to be happening. And most of the Chandrayaan 2 mission earlier mostly controlled by the Earth from the Earth center. And in the Chandrayaan 3 mission, they're going to be the successful of that. They can integrate in different kind of sensor and basic AI tool on these things. That's why in the southern pole also going to be land by Chandrayaan 3 can be successfully landed. So right now, what they are basically wanting the ISRO team that we can deploy some real-time modeling so that it can real-time observe the smoother surface of a particular region and lander can automatically land without managing them from the Earth part or managing from the Earth centers. So that's what we are currently working. So we are going to sign it very soon next March or April a MOU with your team, your ISRO team in Bangalore site. So there our Chandrayaan team and lander team are basically come together and asked to develop different such kind of solutions, mostly the binarized and quantized solution that can be deployed on their edge AI based application. I'll show you some of them, and there are several such kind of real-time application like smart horticulture rover, smart library management, some car parking scenario in real time. We are already initiated in our lab, so if you have time you can go and check these things. So this is basically our solution, whatever we are initiated with the Mars and Moon missions. So here our model is not specifically for one particular terrain. So this terrain should be either Mars or Moon in the future in other part of the globes if they are going to be land. So in that case we have several raw images are there. So we can collect the images in the real time. There are several CTX based camera module, high risk camera module, different set of heterogeneous camera modules should be there. They can often generate the data. When the data has been generated, this can be pre-processed in real time, so it is a total pipeline. So there is no human intervention is required. Then we have some image segmentation models have been there. So initially this is UNet model and recently we developed a new model on that which is called as YNet model. That can basically process on the data and find different part of these things, means crater, rough surface, smooth surface, alluvian fans, iceberg, different such kind of objects there. And these objects are basically classified two ways. One is scientific object and one is basically surface object. Surface object means crater, boulders, rough surface, smooth surface. Scientific object means like alluvian fan, find the flow of the water, the stresses, lines. Then the iceberg, those are called scientific objects. Based on these two features, we need to find a common region, a suitable region where the rover should be going to be land in real-time assessment. Not should be controlled or early pre-trained images we can deploy. So the model will be there, they can be deployed in the edge AI domain which is developed by ISRO team. And then from there we can basically identify those regions or finding the segmentations. Now, when the new image comes, so is that model is a static model? No. When new images it can retrieve, those images again feed into this particular data and model can retrain itself by self-learning mode. They can automatically learn what are the new thing is basically observed and make it more intelligent. So these are the few segmentation thing you can see. There is a different camera modules are there, CTX camera module, high risk camera modules. So we are combining different kind of camera modules are there, and we can find how this segmentation basically working and how we can identify those regions. So if you can see these lines, these are basically alluvial fan lines. But images also still not in the good quality, still we are trying to feed that our model should be working more better way. Right? And before real-time assessment, that lander team also asked us to develop one thing. We have given a specific region. Initially find in this specific region, suppose 25 degree north to 25 degree west of the Mars surface. What is the smoother part where the rover can be landed? First identify these things. Then you can real-time assess this. So then we can collect a set of images bound together and we identify what is the main portion. This is the dark green portion we have identified is the most smoother surfaces. This part is basically required by ISRO team in theoretical assessment 1 year, and this model can be do it by half an hour. And the total matching of their theoretical analysis and the particular model analysis fully matched. Now the team say that no. Now earlier we have a lander team only, now Chandrayaan team also come to us and tell me we can develop several such kind of model, we can sign a MOU with you to develop such kind of models for this kind of different missions. So now we are in the phase, so I hope by March or April they can give us a GPU support and all support to develop such kind of models. Next, in the 6G based mission I can give very brief. So in that case we are basically developing the zero trust solutions, so that we can manage the network part. Currently we are using we are using 4G still now. We say we are in the 5G domain, but in the public there is no 5G domain. Our phone is 5G, but several think that I am using 5G, but no, real time it is still 4G. We are not using India, there is no use case of the 5G till now. But in 2030, Government of India focused that we can develop several such kind of prototyping for the 6G missions. And we are basically compete with the UK and USA and all other parts. Our bandwidth also been fixed till date also. So which kind of bandwidth is going to be given in 2030. But all this bandwidth management and automation, we require more effort and more autonomous things. So for that reason, we require some zero trust solution. There is no human intervention required, and AI basically manage spectrum, bandwidth, all such content more efficiently. And AI basically the part of that, they can basically develop such kind of solutions. So we have initiated several Isaac based solutions that can support drone based applications, several AI native application and orchestrator. One of my students also start to develop one orchestrator based simulator for the 6G, and this kind of simulator is also not yet been designed. So we plan to develop by a couple of next month and try to with the CDAC develop this orchestrator and see how it is working, and we can patentize it after validating with CDAC part. So these are the solution. I am not going detail. So these are distributed learning or federated learning solutions that we are executing now instead of centralized. Different such kind of edge-based application process the data locally, and instead of sharing the model data part, we can share the model parameter. So the data should be protected inside the edge of devices. We are not sharing any information in the network. So most of the data is secure, and for model parameters, we are trying to do some, because model parameter is very limited in size, right? Most of the data is processed locally. So there is no huge amount of data should be transmitted. So automatically our bandwidth automatically be managed. So how we are integrating orchestrator and all this basic logic for automation of the model parameter, that is our main target here. So this is some of the prototypes we are developing. This is in crash. So these are not developed by any industry. I show you in my lab, you go, 2 rovers are there. This is for agriculture rovers. This is everything developed by the students from the scratch by their hand. No industry has been involved to develop such solutions. Every product is being developed by their hand, and they are doing this thing and they are validating these things. And now this patent also been filed and first round of revision done. So hope by few months you can get this. So in that case, here is a local processing. So when the sensor get the data, they can process locally. So there is a 2 different set of rovers are there, and they can communicate each other by processing the data. So these are the few of the results. we are getting by collecting the data, because agriculture domain getting data also difficult. So every time we can go in the field, collect the data and process it by ourselves. So the last one is that we are also integrating, as I told you, that we are sharing the data on model parameters. So now we need to use some cryptographic solution, but we are using the edge-based solution. So any heavyweight model, the current cryptographic algorithm, we can't able to deploy this thing here. Till that, there is only one lightweight model is there, is called ASCON, has been developed, but still it is not been fitted for the 6G based application where more dynamicism is required. For protecting the data and to consider in the edge based application and support for the 6G based scenario, we need to make it more dynamic, because ASCON is a more static approach. Make the network dynamic, so that means our protocol should be dynamic, so that can understand the network parameter and generate the key for based on the messages. So for that reason, we are going to develop some new dynamic authentication mechanisms. One of the students are basically working on that, and they are developing these solutions. And there are several industrial applications already set up those things in our lab. We are developing different industrial applications that can generate the data, process the data locally, right? So if you have time, you can see and visit those things. They can, our students also demonstrate all the working principle of this. So thank you so much. So in brief, I can introduce.
Thank you, Mainak. So we'll now begin our second session, where our respected guests will give us a presentation of cutting-edge research they are leading in their respective domains. First, we'll start with Dr. Joseph, who is a research scientist at Adobe Research in Bangalore. His research interests span multimodal learning, computer vision, and intelligent document creation. He has authored numerous publications at leading venues, including CVPR, ICCV, ECCV, NeurIPS, AAAI, and WACV. His PhD thesis from the Indian Institute of Technology, Hyderabad, won the ACM IKDD and IUPAI Best Dissertation Awards. Before joining Adobe, he was a student researcher at Google Research and a visiting scholar at Embuzai, Abu Dhabi. Please give a round of applause for Dr. Joseph.
Okay, good afternoon everyone. We are just 1 minute into the afternoon. So I'll try to bring in some kind of an industry flavor to today's talk, today's discussions. So I represent Adobe. We are a small company who works in the space of design, let's say giving tools to users to express their creativity. That's what we are into. And Adobe has a small team of researchers, which we call Adobe Research. Globally, we are just around 300 odd people. And we have a small lab in Bangalore. We have 30 people there. And then we work on things that are onto document experiences. The reason is Acrobat and PDF is one of our major contribution. And of course, it brings a lot of natural language processing and related research needs into the system. And then we have something that we call collaborative creativity that has everything to do with your Photoshops and then or even creating your animations with videos and such tools that can help you express that. And the third kind of fundamentals that we can work on is on system designs and so on and so forth. There's a less known part of Adobe where almost a lot of Fortune 500 companies actually use Adobe to run their business. So like if you are seeing an advertisement, or maybe if Flipkart sends you an SMS on what to kind of maybe purchase next, that is really coming from some Adobe software that are running behind the scenes that is helping you understand the user and then trying to model the let's say the product towards the user and so on and so forth. I primarily, by training, am a computer vision researcher, so we can primarily focus on the collaborative creativity angle to it. And most interesting part is it's not that we are an industrial lab. We just care about, let's say, making impact and contribution to our products. But it's more about it. We're pretty open in sharing our information and top venues, which includes maybe we are very like our team over here, the computer vision team. We just started off in 21, 22, and then since then we have been very consistent in publishing top venues on CVPR. I know this is a pretty diverse audience, so I'll just put things into context. So CVPR is like, you know, if so yeah, sorry. So just to ground things into context, I think this is Google Scholar, and then they index all sorts of venues, and which includes journals, conferences, and so on and so forth. So on like Nature, Science, Lancet, and so on and so forth, we're very familiar to the ICER audience for sure. And then the number two is what I'm kind of referring to as CVPR. So CVPR is a major conference, but it's not like a conference like like people. I think that they have some kind of mindset towards journals and conferences. I'm just trying to level things here. So by CVPR, we mean like it's a pretty serious venue that we're kind of talking about. So we are very consistent in kind of publishing our research at top venues, which include CVPR, ICCV, ECCV, and then other ML conferences too, like NeurIPS, IIII, ACL, NLP venues, and PACT, and so on and so forth. Sure. So specifically into what we can do, we work on designs. So this might sound very unfamiliar to you, but if you really think about it, you folks might have seen this. Okay. You folks might have seen this. So what exactly is this? You have some text, we have some images, we have some, you put in some nice little layout, some colors in the background, and so on and so forth. Now this for a researcher is nothing but a multimodal document. And then if you have such multimodal documents, how do you maybe make it better? Is there some way to, I'm not saying that this is bad, but like, can we make it better by the way? Or if I want to create maybe a poster for the event and then I have some just details, if I just key into some system, and then can some system automatically create these. And then once you create it, like, is there some way that can automatically suggest, maybe evaluate this and suggest feedback? So these are some areas that we are super interested in. Why? The reason is, I mean, of course, Adobe has a lot of products in that space. So Adobe has something known as Adobe Express. It's all about designs and design documents and whatnot. And I saw that there's a heavy Canva usage here. Stop using Canva, start using Adobe Express. so we can do almost everything, or rather even beyond what Canva does. So that's what motivates us to do research. But then we just don't do research just for the sake of doing research. So these are some of the papers or works in the design space that we have been into. So. I mean, like two of these works were presented at AAAI last week in Singapore, and another one was presented at CVPR 2 years before as a highlight paper. I'll just give you a gist of these. So I'll just have 30 minutes, and then I will not be able to kind of go into the depth of any of these things, which is not the intention. But the intention is to give a flavor of what we are kind of doing. So I'll just keep that. I mean, limit the technical part until then. So we'll just go in. Like, I'll show some examples of what you have there on generation, editing, and evaluation. So again, I know that I need to give an industrial perspective to today's thing, right? So I'll just talk about one specific part here on this, something known as Designometer, which we published at WACP 2025. And then what we did in Designometer is, like, you take a design, and then we will give a score on how good or bad that is. And now this started off as an academic. Like, we had some interns come over. We had some undergrad interns actually come over to us. And then if you maybe tell a PhD student, hey, I have such a multimodal document, you're going to evaluate that and give me a score, he will probably say, no, this is a completely undefined problem. I cannot work on this. But you give this problem to an undergrad, fresh guy, super energetic, give it to me, I'll just solve it. So that's what they did. So we had a simple Siamese kind of a model that can take these and then evaluate and give a score. Beyond just having a paper, if you go to Express and then you take a design, there are some algorithms that can help you resize these. So you select a design and say, this is landscape, I want to create a portrait version of it. So there are 4 or 5 algorithms that are running and generating the 4 or 5 outputs. And then you have to pick which among these should be showcased to the user. Now our algorithm that is presented in this WACP paper is running behind the scenes on the cloud and then helping users with this. So that's the real value that we are adding to business. The reason is we are getting paid. Of course, we have to do something for them, right? And at the same time, we are advancing the community to, like, by dissipating what we are kind of found out there. So quickly jumping over. So this is about design generation. So again, going back to that poster example that I showed, right? The flyer that we had for the event. Whoever who would have created that would have some mock-up first, and then maybe all the speakers' photo we just send over, so they had to place it somewhere, their affiliation. They did not create the entire thing from pixel 00 to 512, 512 or whatever we had. It was a step-by-step approach. But most of the machine learning, deep learning algorithms, like maybe stable diffusions and whatnot, they tend to generate the entire thing in a single forward pass, done. So we were trying to take a stance here saying that, hey, that's not what you should do. When you do design generation, you should actually do it step by step. So, I mean, so a bit more concretely, maybe you start off with a very blank canvas over there, a blank canvas over here, and then assume a user will come in and say, hey, create a background with a crumpled paper texture, giving a slightly wrinkled and even appearance to it. We do that. And the next step will be overlay a detailed line art of a city street, including buildings and blah, blah, blah. We are going to do that, but it's consistent with what you had before. And if required, you can go ahead and modify this even further. So we have we are building a layer on top of whatever you had generated before. Likewise, I add an illustration of a person and so on and so forth, and you have it here and so on and so forth. So here, we should have a model that can indeed generate things layer by layer, and not just images as images. For instance, if you have street fashion here, you might choose to change its color to red for whatever reason. It should be editable too. So we had one of our first efforts in that space, which we call a sledge. I don't want to scare you away with this huge algorithm, or rather huge model, but just want to, I mean, the key takeaway would be like you have a large multimodal model, that can take in the current context of the canvas and optionally an image for inserting into it, and then an instruction saying that, hey, draw a specific bottle over here, and so on and so forth. So this goes into this large multimodal model, which we have trained, which can generate metadata for the text. So it says like for the text, hey, there's a bounding box from here to here, and there should be the opacity here, and the text should be here, font should be here, and so on and so. We create the metadata for doing that for all the textual part, and for the images we kind of have some kind of a stable diffusion kind of an architecture to create it layer by layer. So I'll just limit the technical details until there, and then show some results where, here are some of the results, from the model after training. You start off with a canvas, and then someone adds a specific, let's say, illustration, and some text, and so on and so forth. So, on the bottom, what you see are all fully generated by the model, without any human prompting. So that is that on maybe generating designs layer by layer. I just want to take into a slightly different flavor of things. So everyone has an Instagram user and so on and so forth, right? So assume you're going to create maybe a poster for maybe your trip or something, or a photo of your trip and so on and so forth, and you want to post it to Instagram. I'm quite sure you folks might have spent a lot of time trying to find the best music track that can go well with it and so on and so forth. So what if we can actually generate a music for you on the fly, understanding the content? What I mean by that is, I'll go to space. It will not play there, but hopefully you are able to hear it. So this is some kind of an image of meditation and whatnot, and what we are trying to say here is like in an ambient composition with a flute and guitar, this is the input to the system. And then what you get as output is what you just heard. Two more examples there. So and just one more. So whatever music that you folks hear doesn't exist. They were generated by the model on the fly, taking into consistent with your image modality and the textual modality, and then generating. So this was presented as a highlight paper 2 years before at CVPR. So I'll just give you a brief insider on things. So what we have here is diffusion models, stable diffusions. They are really good at generating images. So we use them to get image specific details, very abstract details. And then we have a music generation diffusion model, which kind of takes in your text and some kind of music encoding, but this can be noise to be honest initially. So basically you get the text here and then generating music. And then we learn some kind of way to adapt these two big models together, these two streams together. So we come up with a way that is a trainable way where the model essentially, I call it as a synapse, but I know I have a medical doctor here, he might potentially not agree with that, but the idea here is you have some information from your image modality, you have some information from your audio modality, you're going to synapse that in some way so that the model will identify on its own what part of data or what part of information should I fuse from both the modalities towards creating whatever output. So that was another application that we had on designs, and then I'll just switch to another space where, let's say you have these designs and how do you evaluate it? So I gave that example of, let's say, that designometer where we had a simple Siamese model that can do things, which can essentially give you a score. But can we go beyond score and then give specific feedback on how to kind of go ahead and improve a design and so on and so forth. So this was presented at AAAI 2 weeks before, where we were introducing some kind of an agentic system that can help you with maybe evaluating a design further. So just a teaser of that is assume you submit your a manuscript to a journal or a conference and whatnot, right? Specifically to a conference. Let's say this is a paper, and then there will be some kind of a meta reviewer or some kind of an editor, senior editor, who will be finding reviewers, right? So they will find maybe one reviewer, so it's not very clear. This is a paper known as SAM, that's a de facto segmentation model, right? So he will identify that some reviewer who has expertise in segmentation, some reviewer who has expertise in maybe pre-training and whatnot, and then these reviewers will review the paper. They will share the feedback back with the meta reviewer, and this guy is supposed to aggregate everything and then suggest, hey, I'm going to accept this paper if you do ABC, maybe it's not. Paper is not worth it, or maybe this paper is brilliant, let's go ahead and publish. So can we have such a system evaluating designs? Can we model such a system for evaluating designs? That was what we were looking forward in our agentic DRS, design review system approach. So the thing is, like, I mean, we have this design comes in, and then these are reviewers, and then of course, and we are in 2026, and it's like, I mean, if you ask GPT, you give this input design to GPT and say, hey, I mean, evaluate this, give me feedback. It will give you tons of feedback. So our observation here was that most of those feedback, they seem good at the first look of it, but contextual awareness of that, and then truly understanding the semantics behind it and giving feedback doesn't actually exist without maybe. Without kind of like methodological contributions as what we kind of suggested here. So each of the agent here is indeed GPT, but still we have to have some extra layering on top of that to give design understanding to GPT. So GPT is this generic model, right? But the question that we are having here is specific to designs. So what we went ahead doing is, like, we take an AI, like let's say GPT or Claude or whatever be that, and then we have two specific components here. The first component is something that I call as grad. So this is an exemplar selection model which selects the closest design using some kind of a graph matching algorithm to kind of instantiate the design awareness into GPT. And then we have something known as a structured design description, which is basically letting the model see the design not just visually but more in let's say in words. For instance, we're saying that, hey, there's a specific sign at a specific location and whatnot. So this actually helped, and what better way to kind of show a result by just evaluating the poster that we have here. So we gave this to this internal model, and then maybe one feedback we make is like ensure consistent spacing between the sections, like inauguration, program details, feedbacks, and yeah, it seems logical to give such a feedback, right? So yeah, so that is what I really want to cover, like just some grounds on the very brief high-level ideas of what we are doing, what are we up to, why do we do it, and what is the incentive for us pursuing these. So just one last thing. So I mean, Zakaria, who had invited me over here, had told me that, let's say, spend some time on some non-technical things also. Like, it's a lot of young audience here, who are maybe pursuing their masters or PhD or undergrad or want to do some research. So just sharing some insiders on, let's say, I'm just flashing 100 different papers, or maybe saying that it's for 10 papers in CVP or 20 papers here and there. But what actually goes behind the scene towards creating these papers or towards doing research, that is pretty, I mean, like, at least it seems that we're doing good. So just 3 points, I'll just wrap it up. So do what you love. Your thesis or your PhD work and so on and so forth is yours. It's not your advisors. They're not gonna. They don't get anything from it, right? So it is like, do things only that you are passionate about. So very specifically, when I started off, I had a chance to attend a conference on ECCV, and then there was some workshop that was happening on continual learning. I picked up continual learning from them, and I came back to my advisor saying, hey, let's have continual learning, this seems interesting, can I work on it? Then I was like, yeah, of course, let's do it. So right from day 0, I was owning the problem. It was not my advisor, or it was not anyone else. So there has been a lot of ups and downs along the way. I mean, like, so I still recall, I mean, one of the papers that we had, I mean, I was interning at a university in Abu Dhabi. It was not a university, there was a research center in Abu Dhabi. So, I mean, that's when, it's in 2019, December, what is so famous about that month, right? That's when COVID came out. So, and then I was stuck in Abu Dhabi, waiting for a one-day pilot flight back to India. But we, at that point, we had submitted some paper to a conference on a CCCB on incremental object detection. And then I had some idea on, let's say, how do you maybe, when you detect objects incrementally, there's always a situation that, there will be some objects that you really don't know in your system, right? So, so we had that idea, we just had that idea. But then that's when COVID came, everything was a mess, and like my Vande Bharat flight got delayed, cancelled 2 times, and stuck in Abu Dhabi. But even in that stage, I was so passionate about whatever I'm doing because I was owning. I convinced my advisor to work on that space, so I was owning the whole stuff, which led me to kind of continuously work on that. And the output is a paper that we had at CVPR, where we introduced something known as open world object detection. And that has turned out to be quite well. It has over 800 citations as of today. Which is the impact that we had. But the only reason is I was passionate about it, and it was my research, and so on and so forth. So that was my tip number 1: do what you love, because research they will have up and down, just like we human beings have, right? It's never a straight path. So unless until you do something that you love, you will not have the energy and bandwidth to carry it forward. So second one is be organized. Going back to my example of that in 2019, 2020, I tend to be very, very careful about what I do. I maintain some kind of a ledger of whatever gets happening at each time. So this is March 2020. And then at each time I know what are the papers that I read and what are the main summary that I had with my advisor and whatnot. So this, and then even now when I reflect back, I can see the evolution of the methodology that we came out with. Where maybe we had some random ideas coming in, and then my advisors coming in and giving me, it's 2020, giving me detailed feedback. This deleted user is me because I am done with my PhD, so my university address is got kicked out. But this really helps you to kind of be on track, because a PhD student, it's less of, let's say, that idealistic setting where you have a beautiful lab, you sit in the corner of your lab and then work undisturbed. That's definitely not going to happen. You are in a matrix. You will have influences from multiple things. You might be TAing for a course. You will have family responsibilities and so on and so forth. So having something to latch back onto when you are thrown out would really, really help. So that was my second point on being organized. And then I'll just stop with the last one, which is failures are truly, truly, truly blessings in disguise. So when I started off, I submitted a paper, my first semester to a conference known as VACWI. It was pretty well, so this VACWI, not many people might know about it. It has a setting where you can submit a paper in round 1, get feedback, improve your paper, submit round 2, and so on and so forth. Round 1, we got the results. Borderline accept, weak reject, or something. I was happy. I got one borderline accept. We worked on this really, really hard. We submitted it. But then we submitted it as a fresh submission, not as a follow-up, because we thought we had done an enormous job there. The result was reject from 3 reviewers. That was good because I eventually submitted that to another conference known as ICIP, which is not at the scale of CVPR or ICCB, and the result was reject. So essentially, at the end of the day, it got accepted to a workshop at ECCB, and then I went there. I could meet a lot of people. I picked up my thesis topic from there and whatnot. So had this paper has been accepted at VACWI in the first place, I would not have done my research in the specific area that I was super interested in. So always take rejections positively, and that's it. So that's pretty much what I wanted to cover.
Thanks, Joseph, for this amazing talk on the background, what goes behind the scenes in research. We'll do a short Q&A. Let's do 2 questions from the audience. Do we have any questions? Any questions? Yes, great.
I'm on the spotlight, please.
Sir, thank you for the great talk. I just wanted to, it's a very general question, and I'm sure you've been asked this beforehand as well. Where are the training data sets coming for all of this?
for whatever we can use and do at Adobe, data is something that we are very, very careful about. So we have models, like there's something as Adobe Firefly, I'm not sure whether you heard about it. It's also an image and audio and video generation models. All the data that we use for training those are licensed for us to train. So, and then we don't get out of that guardrail that we have, and that's the reason why we are not competing with GPT and so on and so forth, because the data is risky.
I mean, it's kind of controversial that the use of artists and the AI is taking over
Yes.
artist space. So
Yes. So I mean, see, I think we did hear that example of, let's say, like a few years before, when our director and was continuous learning about either doing the early research, they used to do things on, let's say, that sheet where you used to write down things and then project and so on and so forth. Then came slides, and then so change is there. I mean, I think change and AI, it's quite sure that it will change everything in multiple fields, right? So if you're not embracing, I think you will be left out. And yes, it's going to happen.
Thank you, Joseph. I will invite our head of the department, Priyanka, to kindly give the memento for the guest. Next, we'll invite Dr. Kesav Das, who is an Indian neuroradiologist and professor specializing in neuroimaging techniques such as functional magnetic resonance imaging and magnetic resonance spectroscopy. He serves as a professor senior grade and the head of the Department of Imaging Sciences and Interventional Radiology at the Sri Chitra Tirunal Institute for Medical Sciences and Technology in Thiruvananthapuram. He has been a faculty member since 1995, where his research focuses on neuroradiology, particularly neuroimaging in epilepsy, brain tumors, stroke, dementia, movement disorders, and pediatric cases, alongside innovations in functional near-infrared spectroscopy. He also works on brain-computer interfaces and medical imaging informatics. Dr. Kesav Das has received many prestigious awards, including the National Bioscience Award from the Department of Biotechnology, which you may know is one of the highest science awards given to him for his contributions to biosciences in 2009. Please give a round of applause for Dr. Kesav Das.
So I am a radiologist. Can you hear me? Is it bad? Yeah. So I am a radiologist working in Sri Chitra Institute of Medical Sciences, which is about 25 kilometers from here. And as you know, radiologists are people who look at medical images which are acquired from various machines like MRI, CT, ultrasound, EEG and all these things. Put them together, look at the clinical details of the patient, symptoms, signs of the patients, and come to a diagnosis. So they work along with the neurologist, cardiologist, gastroenterologist in bringing the diagnosis and then help in management of the patients. So that is a neuroradiologist, and I am a neuroradiologist basically working on brain images. So whatever I am going to talk today will be mainly focusing on brain. So if you take a brain image, so this is an MRI image, and this is an image by positron emission tomography. The two images are acquired from different machines. The magnetic resonance imaging gives an information about the structure of the brain. So whether there is a tumor in the brain, whether there is blood in the brain, that the magnetic resonance imaging gives. But the functions of the brain are not very well picked up in magnetic resonance imaging. Of course, there is a technique called functional magnetic resonance imaging, but not as much used as positron emission tomography. Positron emission tomography gives an information about the metabolism or the function in the brain So is there an area in the brain which is more active, or whether there is hypermetabolism which is happening, you can get an information with positron emission tomography. So you need both informations. You get the structural information, you get this, the functional information, you try to co-register it. So co-registration is a technique which we have been using for quite some time. From the 90s and to now, we are regularly using co-registration technique, which has its own technical problems when you start co-registering two completely different data. So this is the medical image computing which was existing in the 90s, but during those times it was not as frequently used. Now any digital image, and I come from a time period when the images were analog image. Like when I was an MBBS student, there was no computer. When there was no digital image, it was all analog images. But what the digital image did is it made a big change. When you could see images, you could improve the quality of the images by looking at certain parameters in the image, and that is called the spatial resolution, temporal resolution, which looks at the time points, contrast resolution, which looks at the contrast between black and white, contrast between pixels which are close by, spatial resolution, how close the pixels are and how good you could see the images. So this was what was possible, but the problem in imaging is there are techniques in MRI, or you take single unit recording, patch clamping, EEG, MEG, all of them have some problems. Some of them have a very good spatial resolution, but the temporal resolution is not very good. Or it could be the other way around. So electrophysiological recording, positron emission, magnetic encephalography, all have some advantages, some disadvantages. So that means there is trade-offs. There is trade-offs between these imaging techniques. Suppose you want to image the heart. What is the most important thing? For the heart, you need the temporal resolution to be good, isn't it? It's a moving structure. So you get a good temporal resolution. But then what happens is, some of the images that you get out of it might have a lot of artifacts because of the moving structure. So you want to remove that artifact. So the image processing techniques have been devised by which the disadvantages of one of the technique have been removed by medical image processing. So these trade-offs are always there, and so people have developed post-processing techniques which actually improve the final image that you get by medical image computing. The second point is what Dr. Rajiv was discussing is MRI imaging or any CT imaging, ultrasound imaging is now slowly becoming quantitative. What is the problem of qualitative imaging? Qualitative imaging, if I am looking at an image and another doctor is looking at an image, one person could say this is bright, the other person could say that no, this is not very bright. It is very subjective. So we have to make imaging more quantitative. There is values in that image, quantitative values. And in MRI and CT and ultrasound, there are certain values which makes the black and white image or the color image. So that is the second thing which has happened in imaging. Also certain diseases. There is these white areas that you see here, these white areas are seen in a disease called multiple sclerosis, which happens in the brain. So the number of these lesions, these are called lesions or areas, you can call in simple terms, they increase over a period of time. We want to know how much of the brain is involved. So you have to actually do a measurement of these areas and take the total amount of these areas in the brain, which is called the lesion load. Can you imagine a radiologist sitting and drawing all these things in some maybe 50 of such areas? It may take about an hour's time. So it is almost impossible. So what doctors used to do? They never used to report it. It's tough. I want to report an MRI within 5 minutes or 10 minutes. I am not going to do the lesion load. So many of these things were there in medical image computing, We could draw it, we could complete the measurement and tell that this is the quantitative value of the lesion load, but nobody was using it because it takes time. And then the quantitative susceptibility mapping, which Dr. Raji was telling, is where you measure the iron quantity in the brain as the brain gets older. So if you get a quantity of the iron, it is much better than if you do not have the. So people were not using all these things. Quantitative methods were kept at the side because it took a lot of time in quantitative measurements. So recently, I just wanted to share this information that I had gone for a conference. This is about 3 months back. And I went to the stall of BPL. Some of you might have heard the BPL Limited company, which is coming out with many of these imaging equipments. So I was very much thrilled to see one equipment which is a very simple portable X-ray. So portable X-ray is taken for patients who are lying in the ICU, who after a cardiac surgery or some neurosurgery or any of these major surgeries in the ICU, and the lung whether is recovering normally after the surgery, because they do the anesthesia, they put tubes and all, they want to see whether a lot of fluid is collecting in the lung or not. So all these things have to be done. Now, as soon as the X-ray is taken, that image which is comes on the screen, the digital image comes on the screen. But there are only nurses there in the ICU. Sometimes a junior doctor may be there. Usually there won't be a radiologist or there won't be this cardiac surgeon who has done the surgery, because this would be happening at night. Maybe 12 o'clock this X-ray would have been taken. But what I could see is that image was being created, and within about 5 minutes you will see what is the diagnosis also now. Whether there is a lot of fluid developing inside the lung. So this information can be immediately told to the cardiac surgeon or the radiologist and inform that this problem is there. Doctor, please look at this image. So the nurse could just inform that. So it is by an AI method that you could actually pick up that there is water in the lungs. So very important information. Similarly, there was another machine which was from a company called United, which was coming out with brain health. So anybody who gets a scan done immediately gets an information about the health of the brain, just like you get after the blood test, you get the information about your hemoglobin, your various parameters, TC, DC, ESR and all these things. Just like that, after a scan you get an information about the brain health. This was all not there before this AI, because it calculates the volume, it calculates the amount of iron in the brain, it calculates about the white matter damage in the brain. It might be different in a person who is 30-year-old versus a person who is 65-year-old. So the brain health is different, and you can get automatically such an information. This is synthetic MRI. It's another technique where you are making synthetic images by means of the sequence. This is a multi-dynamic, multi-echo sequence. A special MRI technique is done, and from these images you get synthetic images which gives information, the quantitative values. So what are the quantitative values in MRI? It is called the T1 relaxometry, T2 relaxometry and all these things. So these quantitative values you get multiple contrasts. So with one sequence you are getting multiple contrasts, as you can see. This is one, this is another sort of contrast, this is a third type of contrast by single technique. So similar is the case with Alzheimer's disease or epilepsy, where you are looking at certain organs inside the brain, like the hippocampus. You want to see whether there is volume loss in these structures. That again is possible by a quantitative method. This is in Alzheimer's disease, where you are looking at the size of the another structure called the insula or the Heschel's gyrus. All these informations you get, and these are some of the works that we have done with various institutions. This was a work which we did a long time back with the University of Cochin, where we were looking at whether you can differentiate a normal brain versus a person with mild cognitive impairment, which is the MCI, or the Alzheimer's disease by some sort of a classifier. And this is now, a lot of studies are available. The technique which I told about brain health, which the company United has come out with, actually gives a value of all these, the classification, the segmentation, the volume calculation of the brain, everything is obtained within 10 to 15 minutes. Again, some of these works which we have done, other than the volume loss, there is a change in the shape which happens during the lives. As the brain gets older, it becomes more convoluted, and that sort of this thing can be measured by fractal dimension. And then is the work on segmentation. So this is a brain tumor, and many of these patients who come with brain tumor, what is usually done is you have to do surgery of these patients immediately. But some of these tumors you can wait, because some of these tumors occur in areas of the brain which are very important, and you remove the patient sometimes might get weakness, cannot speak after the surgery. So in such cases, sometimes you wait for some more time. But then you have to measure the size, whether it is increasing or decreasing in size, and using techniques like segmentation, we can do it now. Now, why do you want all these segmentations? The same thing which I was telling. Previously, MR reports that we used to report never had the complete segmented brain volume measurements, which is now extremely essential, because any small increase in size can be actually picked up. The next thing is you have low quality images, poor quality images, because your technique which you have done for a patient who is moving could be having a lot of movement artifacts, or could be due to artifacts which are produced by the MRI itself. So such poor quality images, as you can see here, have to be improved to qualities like this, and you have AI methods to improve the quality of the images as well. There is a technique called arterial spin labeling, which gives information about the perfusion of the brain. Now you see these are low SNR images, but it takes about 2 minutes for scanning, while if you want to do a high signal to noise ratio arterial spin labeling technique, that's a perfusion imaging in the brain, it takes about 8 minutes. But by producing a synthetic arterial spin labeling, you have a low SNR sequence, but quite a good SNR is obtained with a lesser amount of time. So these are some of the other works which we are doing. This is one work which we were doing with NIT Surathkal. Now, in patients who have seizures, epilepsy, usually have some sort of a lesion in the brain, a pathology in the brain, which is called a focal cortical dysplasia. And I am very sure that even to the doctor community, it is not very well visualized. Sometimes you can miss these lesions. So can computer pick up these lesions or this pathology, which the human eye finds it difficult to pick up? And this was a challenge that we gave to people in NIT Surathkal. And they worked on it, and they initially came out with some diffusion techniques by which you could pick up these lesions, but this is one of our old papers. It was picking up too many lesions, and then it becomes again a problem for the radiologist to go back to look at all these images and say which is actually abnormality. But with the availability of newer methods, now we are able to segment these lesions very well, find out these lesions in a better way, but still we are not what we really wanted. That means to pick up these lesions which the human eye misses. So there is a long way to go, and we are still working on this. More challenges are being given to our friends in Surathkal, and they are still working on it. During COVID also we worked with IIT Palakkad, and there you remember we could the doctors or even the number of nurses who could go near the patient who had COVID was very less. So at that point of time, only probably one nurse would go to near the patient and take some images by ultrasound scan at different angles. Now these angles, these images were by an AI method, we found out methods by which we can detect the pathology of COVID and also differentiate it from a pathology like pulmonary edema. It is a totally different condition. Or we could differentiate and find out whether the lesions are decreasing over a period of time. So this is very important. Actually, there was a recent work which was done in All India Institute of Medical Sciences, where the ultrasound scanning is done in Antarctica and the reporting is done by the images by AI methods in All India Institute of Medical Sciences. So such technique, far away patients, you can scan and get the results. This was one of the earlier works which we had done on a technique called MR spectroscopy, and we were looking at machine learning methods to look at a glioma, a tumor in the brain, say whether it is malignant or not, by means of the various protocols. So if you look at different AI methods in neuroradiology, there has been changes at each of these steps. Acquisition of the images by the imaging technique CT or MR, the image reconstruction which Dr. Rajiv was mentioning, in the image reconstruction area, that means within the MR you can do a lot by AI based methods. Then during the pre-processing and the post-processing methods, that is the segmentation, the volume calculation, and at all these levels AI can be used. Feature extraction, so there are certain features which you have to identify in each of the tumor or a dysplasia or a disease. That features can be extracted. Classification of the disease can be done. A better visualization can be done. So in all these things AI has been used in medical imaging. But what is most commonly used is for a better workflow in a radiology department or in a hospital. So what is this better workflow? So when a patient is coming to a hospital or a medical center or an imaging center, we have to triage the patient. Or when a report is given, we have to triage and tell which are the reports which we have to give early, which are the reports which we can wait. Similarly, the AI tool can actually scan the whole of the report and say whether the report is correct. So suppose if there is a report, say the name of the person Anu, and in that report it is written the ovary looks normal. Now the AI tool picks up that it is completely wrong, because it's you have written Anu male and in the report it is written that. So it is flagged off. Such reports are flagged off and told that there are mistakes coming in these reports. So and similarly there are huge amount of medical data which is coming. And from this medical data you need to pick up important things which are needed for the radiologist. Or the radiological reports itself has a lot of information. Get the concise report. So such work is a better workflow of a hospital or a radiology department. This is the work where maximum work is going on, and a challenge today, and you can take up such challenges more than what I have written here, because these are more challenging and this many times needs an industry collaboration. This is something which you can adapt to your hospital, your computer departments can start working on this workflow problems. And by working on these things, you are also working on important information as far as the patient is concerned. Today, the most important thing is diagnosis of the disease and treatment. But you know that it is not just therapy which is important. In many cases, prognostication, how the patient will do after maybe 3 years, 4 years, that is also important. Similarly, monitoring, a patient is being given a drug and how the patient is adapting to that treatment, that is monitoring. That again is important. So AI will play a role in each of these aspects, though the workflow management will be the most important area in which predominantly we will be working on, and most of the institutions and industry are presently working on these areas. But I am still very much thrilled about techniques like the synthetic MR images which has been created, or by image reconstruction methods. If you can do a low dose CT. So what is a low dose CT? You are irradiating the patients, you are giving radiation to the patient. It is harmful So can there be techniques by which you can reduce the dose by means of reconstruction methods? So at the reconstruction method is made different by the AI method. Similarly, can fast MR imaging be done and you work on the post-processing of the images and make the images good by means of image reconstruction? One of the work where maximum work has been done is on stroke detection, early stroke detection, and you have this thing called aspect score. So soon after, when the patient comes after stroke, a CT scan is done, you have to tell that there is no hemorrhage. So this stroke would have happened in a remote village, and it takes a very long time for the patient to come there. So somebody, a technician there would have done the CT scan or the MRI, whatever it is there. Usually the CT scan, because MR might not be there. After the CT scan, there could be some abnormalities which the technician is not able to understand. And you have to get a score by which the next treatment is decided, a score of the brain imaging, and that is called the aspect score. So you give values to each of these particular areas and then see whether a blood vessel has been obstructed. All this information has been captured by the AI and told that there is a large vessel occlusion and the aspect score is so and so, say 6. This is the patient for thrombolysis. So this is what is happening. It is very important because decision on whether to treat this patient by means of thrombolysis or whether the patient has to have a thrombectomy is decided by the AI technique, and then based on that decision the patient is sent to the hospital where thrombectomy is available. So suppose our hospital has thrombectomy, the general hospital here might not have that thrombectomy being done. So this sort of triaging the patient as well as detecting the abnormality has been very commonly used in most of the Western countries, and the only problem is we can also adapt to these techniques, but at present some of the software which is available for these are very, very costly. Similarly, picking up a small hemorrhage in the brain after an accident, the scan center will not have a radiologist to pick it up, and you pick up these lesions or abnormality by means of AI methods. You have to inject a contrast medium, usually iodine or gadolinium containing contrast media into the body and get the images. But if you can do it with a smaller amount of contrast, it is always better, because if you inject 10 ml of gadolinium, the cost to the patient is high. Also, it is not good because you are giving a larger dose. So can you reduce the dose, just 3 ml of contrast, and get the same sort of images? So that is what the AI methods can do. However, there are problems. Like you see, this is a method of MRI reconstruction done by deep learning methods. And when you do it by this deep learning reconstruction methods, there is a possibility that you can miss some of these abnormalities. So there are still a lot of work to be done, because there are some things which are being missed, and this you can do only when you start using these deep learning methods. This is a work which we had done and published it. This is a zero echo time imaging method, which we wanted to see how good the MRI picks up abnormalities in the skull. So CT scan is a good technique to look at the bone. MRI is not. Bone you cannot see. The skull problems you cannot see. Inside the brain, whatever it is very well picked up by means of MRI. So can you get the information of CT scan also using the MRI? You can make a synthetic CT from the MRI image, and this is the actual CT scan. This is the synthetic CT scan, and there is an abnormality here. You see the abnormality is also picked up in the synthetic CT scan. So with one method, MRI, you are getting information of both MRI and CT scan. It's a wonderful thing which has come up there, and it is completely developed by some of the AI method, and this paper has been written by Kaushik. Of course, he works with Siemens and is in Germany, Indian working there. But a lot of good work like that is coming up, which will be of extreme use. Two other areas where a lot of post-processing is needed is functional connectivity, the brain how the brain functions, and you have various methods. More of the methods are known to all of you, which and similarly there is another technique called diffusion tensor imaging. Again, white matter tracks in the brain, and very labor intensive post-processing methods. Now these methods gives information about the various connections in the brain, and this connectomics, that is what it is called, is different in a patient versus a normal person. So the post-processing methods are difficult, and the final result that you get will be very useful in management. But people are not using it. If you see the world around, people are not using, because the post-processing methods are very difficult. So, but now with application of AI in the functional MRI, you have automated the whole resting state of MRI, and diseases like mental health problems and neurodegenerative problems and patient-specific problems have been much better evaluated. Similar is the case of diffusion tensor imaging, where diffusion tensor imaging method, where the white matter problems have become a biomarker. Now, a technique which was not used previously because medical image computing was quite difficult, now it has become much more simpler. Classification of the brain tumors, and the next technique which is coming up is the feature analysis on diseases, which is called the radiomics, and combining it with genomics. So suppose there is a patient with brain tumor. Previously, how was the patient treated? All the patients were treated alike. The same sort of management. The drugs that are going to be given, the chemotherapy that you are going to give is almost similar. But now people have understood that treatment of diseases is also based on genomics. You get the clinical information, you get the radiomic information from the radiological images, you get the genomic information from the genetic evaluation, get all these data together, and then decide on risk stratification, early diagnosis, treatment selection, treatment response, and prognosis. This is large data, working on large data, and putting all these things together, which actually it's quite difficult for a human intelligence to do, and the artificial intelligence is coming in a very big way, because the segmentation, feature extraction, classification, all involved in radiomics itself took a long time. Now, by means of deep learning methods, all have been combined and made much easier. However, there are ethical challenges when you are having a medical data. What is the profit of data? So you are taking the patient data. What does the patient get back? You are taking 1,000 patient data. Does the patient get anything back? Only the cost of his treatment is going to go up, because the scientists who have developed these AI methods is going to take money from this particular patient. So this is something a highly debated topic. So when you are developing AI tools for patient care, should the patients get some benefit, at least in the sense that the cost of their treatment does not go high. Protection of data privacy is important. As you know, there are a lot of laws coming in different countries, and that we were talking about federated learning. It will definitely help in the protection of data privacy. The quality of annotated data, it can be very different. You do in one center, you do another center, 3 or 4 centers. Some of the quality will be very good. You are putting all these things together for your training your data, and ultimately even for validating all these things is going to be a problem. This collaboration of AI experts and radiologists basically is quite less in our country. That's what I have seen. Much better abroad, and that will definitely be a very important thing, and these meetings like this will be very useful. You create a model, and then if that cannot be reproduced, then what is the use? So it just becomes a paper and nothing more. So it is important that when 2 academic institutions start working on these areas, one with a lot of expertise on data, the other good expertise on medical management, the third component, the industry, is very important, because ultimately if it has to have any use, industry should be roped in, and we should do the validation and even any testing of these data with the help of the industry. There is a bias, equal distribution of AI. So suppose the study is done from the data you get from Sri Chitra Tirunal Institute of Medical Science, my institution. Suppose you get the data from a district hospital or a primary health center. This data will be all different because the type of patients coming to this district hospital and the type of patients coming there, or the type of people coming to King's Hospital, a private hospital, Anantapuri Hospital, will be different. A type of diseases will be different. So your data will be completely skewed. Or you are doing a study in Assam, you are doing a study in Kerala, again data will be different. There are the types of diseases, the brain morphology, everything could be different. So these things have to be taken care of. That is the bias problem. So you develop an AI model, who is liable for the mistakes that it creates? I showed you a case where it meets the issue. So the liability part is important, and the case numbers. Nowadays you can publish papers with 30 number of cases, classification, which is not correct. It has its own problems. So these things have to be looked into whenever you work on AI. And this was one of the slides which was given to me recently, and you can see that how AI is going to change the world. And I'm not quite happy with doctors and surgeons. They're saying that by 2032 we are going to lose our jobs. We will be just liability managers. So I don't think that is going to happen. It will take time. Even the surgeons will be replaced. That is what is being told. There is much more to it. When you actually start using it, only then you will understand that more than somebody's job being lost, it is a tool which will make things much more easier. A quantitative method which I was never using earlier, now I have started using it for the multiple sclerosis case which I showed you. So the most important thing is adapting and integrating. When a technology is developed, and I have been working with GE, Siemens, Philips, Samsung and many institutions, they come out with wonderful tools. Whether it is AI or whether it is any other medical imaging method which comes up, it's all very good. But how many doctors actually use it? Very few. How many doctors actually have it? And how many of our patients actually are able to utilize it because of the cost involved? So these are all important, and adapting and integrating is something which we have to really look into, especially when you start using AI technologies. Thank you.
Thank you, Dr. Keshav Das, for a deep insight into the applications of machine learning in medical domain. We'll take a few questions once more. Yes, any questions? So, Dr. Keshav Das made
medical domain.
Medical.
I don't know how many.
How many of you would trust the output of an AI algorithm diagnosing some disease for you? Maybe just raise your hands. So instead of a doctor, let's say there is an algorithm telling you have certain disease or not. How many of you would trust such an algorithm?
So everybody is selling like this. So I am happy. My job will be still there. So one thing, there is still a lot of work to be done on the workflow part, and I think if you want to take up projects, you also try to look at such projects where hospital workflow will become much more easier, which is nowadays with so much data coming, it is so difficult for doctors to really work on all these data. So if the workflow management things, which there are a huge amount of things, if you talk to doctors, you will get a lot of information. So there is a very important information is a very close collaboration between doctors and AI scientists are required in this. Thank you.
Thanks. Can I request Dr. Priyanka to hand over the memento? Next we have our beloved Dr. Deepak Mishra from a very nearby institute, Indian Institute of Space Science and Technology, Trivandrum. His research spans computer vision, image processing, machine and deep learning, signal processing, biometrics, and information security. He also works on mathematical modeling with applications in computational neuroscience. He received his PhD in electrical engineering from IIT Kanpur and completed his postdoctoral research at the University of Louisville, USA. Prior to joining academia, he worked as a senior IT engineer at CMC Limited, Hyderabad. Currently at IIST, he has served in various academic roles and is currently the head of the Department of Avionics. Dr. Mishra has been actively involved in various ISRO-supported projects, including satellite image fusion, high-resolution remote sensing analysis of landslide and land use classification, and virtual reality-based disaster simulation systems. Please join me in welcoming Dr. Mishra.
Good afternoon. I know you all are hungry. So anyway, I will take whatever time given to me and then rush in when I finish. So I thank Hunaiza for inviting me to this symposium. And my topic would be a little different than you already had listened. I think Dr. Kesar Das and Dr. Joseph has talked about various aspects of how AI has been utilized for animations, creating graphics, and then for the medical as well. I will take you to the little more on the remote sensing side because I am coming from Space Institute, so I will be talking more on this thing. So I have chosen the topic basically on harnessing recent advances in deep learning for weather nowcasting and road extraction. So there are two different topics I wanted to talk today. These are the work done by my PhD student. We have a joint project with ISRO. One is with SAC Ahmedabad, other is the ISTRAC Bangalore, and these are the part of that work. And all of you know that weather and smart cities are the two frontiers of geospatial intelligence, and we know that our planet is changing very rapidly. And then there are two aspects I'm talking about. One is basically predicting the weather, whether it is first of all possible or not. First question, this comes there. And then can we use the AI technique for urban planning and smart city? Now many governments are using this word smart everywhere. So what is it smart means actually? So smart means using better algorithms for coming up with the real solutions. Like nowadays you see that weather forecasting has become much more accurate. When earlier I remember whenever IMD used to say that there is going to be rain, then people will go for shopping because they are 100% sure that it is going to rain there. But now I think it has changed. The data assimilation techniques and then methods have been much more better. And if you just see GraphCast and new generation model from Google and various good companies, they are predicting weather in 25 minutes, 10 minutes kind of a thing. So basically, just to introduce weather forecasting, basically understanding the dynamics of a planet. An atmosphere is very highly nonlinear. It is multi-scale and strongly spatio-temporal. And then data sources are mostly diverse. We have satellite data, radar data, reanalysis data, in-situ observation. And what are the key problems? Short-term forecasting is uncertainty is there, error growth over time, and then high computational cost of physics-based model. So this is the another very important aspect that we have to worry about. And then getting the data from different sources is very, very challenging. And then there are some errors, like how do you collect rainfall data? And India is a big country, and then tropical weather forecasting is much more difficult than any other weather forecasting. And then, but you see that a lot of weather satellites have been launched, a lot of weather stations are there. Even in Ponmudi, you are very near to Ponmudi. Anytime cloud would change and then suddenly it will start raining. So very dynamic weather. So how do you predict such kind of a thing? It's very challenging, and that's where data-driven approach like machine learning, deep learning can be useful. Another aspect is smart cities. Basically, this is kind of a understanding a complex built world. So this is kind of a, you see that this is the kind of a roads. From satellite, even all you see is Google Map. Everybody might have used Google Map and Uber, booking app, and now Instamart. You just see where the person is traveling. How they digitize the entire, Earth, and then brought that into the mobile phone over a cloud, and then now you see real time where is the person traveling. So first is to detect the road pixels from the satellite, and then imagine the satellites are of different resolution. Resolution means some are 30-meter resolution, 10-meter resolution, centimeter resolution, and typical width of a road is around 7 meter and beyond. If you go to a smaller road, it is 3 meter, 5 meter. Sometimes it's a muddy road, sometimes it's a tar road, cemented road. So there are many kind of a road pixels are there. How do you from satellite image can detect whether it's a road pixel or it's a river pixel? So how do you find? It's kind of a little segmentation approach that is very important. Same thing is also useful in medical imaging. Let's say you want to detect arteries and then other kind of a very highly nonlinear shape. That is also a challenging problem as the road extraction. So there's again, this is a problem, dense and heterogeneous, rapidly changing, highly sensitive to scale and the resolution. And high resolution satellites and aerial imagery, so sometimes people fly drones to capture the image. So this again, you put a camera there and then you take the images. And then massive spatial coverage is there. And then what are the key problems? Accurate expression of road and infrastructure is very crucial. And it is robustness to occlusion, shadows and variability, and need for a real-time update. Actually, you should detect road in real time. In terms of if you're flying, you want to plan some GIS placing, then it is very important. So in one of the work, we have focused on how deep learning can be utilized for road extraction. So why these problems are so different yet similar? Because if you see the aspect in weather forecasting, the nature of data is dynamic and time evolving. In smart cities, it is largely spatial and high details. Scale, it is regional to global. Sometimes you want to predict weather in Vidura, other time you want to predict in Trivandrum, maybe in Kerala state or maybe in India. Okay, so that's again scale is a different. Again, it is local to the city scale. Maybe road extraction in this city may be different than the road extraction in the highways. And complexity is physical and chaotic. A lot of physical phenomena, let's say temperature, humidity, all this can change the weather very effectively. And then there's a structural and visual aspect has to be there in smart cities. And common is just too complex for the handcrafted road, and it is also very complex. You cannot make the, if it is a black pixel, it is a road, or if it is a this much width, it is a cyclone. So like kind of a, you cannot just make a handcrafted road. So you have to have some intelligence approach. And why deep learning? Again, deep learning is now old. People are talking about generative models, LLMs and other things, but essentially it's all come under the deep learning aspect. One thing is automatic feature learning. So deep learning allows you to extract the feature automatically from the data. So even if you don't have expertise, what is good feature for a classification, it can give you the right possible feature. It can handle large and heterogeneous data. It can generalize across space and time. And then deep learning enables learning these spatial pattern, images, maps, learning temporal evolution, multimodal data also you can give. You can give satellite data, sound data, anything you can mix in the deep learning aspect. And first of all, it has allowed you to end-to-end modeling without explicit tool design. So that's one of the advantages of deep learning. So one of the work that we are doing is called structure-aware road extraction from high-resolution remote sensory images. So what is the idea? Given this image, this is the ground road, and we have to classify pixel as the road or non-roads. So it is a very simple segmentation problem. But if you see that detecting road is not that easy. I mean, if you just see this image and ask you to draw the road pixel, you will have a lot of hard time doing that. And then imagine how much effort human has to do for detecting roads. So that is one problem, and then it's useful in autonomous driving, road network planning, traffic control, management, map navigation, smart city construction. And then people have used these morphological feature-based models, usually which is suffer from lack of robustness and occlusion, light and contrast variation. And handcrafted feature-based method also suffer from challenges like occlusion, weak extensibility for different data sources, and difficult to best parameter selection. So what are our research objectives? We have done 3 work. I will be presenting 2 work here. So the idea is to first, when we began, we started to use UNet. I think many people use segmentation with UNet only. Okay, and then we extended our work to a new, very fancy model. It's called Kolmogorov-Arnold network. It's also one of the very fancy architecture, and it gives actually the different decision to the problem. It basically you see the problem a bit differently. And then we have also had some fractional aspect to that thing. So what is the basic idea? So I will not read all those things, but what the idea is, we built a single experimental workflow that every model is trained and tested with the same pre-processing training settings and evaluation criteria, making the comparison consistent and repeatable. That is the first thing you should do. Otherwise, you are comparing apples and oranges. So you have to fix your benchmark. This is the data I am going to use. This is the pre-processing, and these are the method I will use to compare things. And we also report practical computational data, how fast the models train and run, and how many parameters they use, and how demanding they are to compute. We also focus on how utilizing 2 or 3 convolution layers in each block affect the performance. And we also examine different loss function and combination of the loss function to see whether does changing the loss function affect the overall formulation or not. And then we evaluate the cross-domain performance by examining the transferability of the models trained on one data set to the others by emphasizing satellite to satellite and satellite to UAV generalization. So basically you take one satellite data, test on the other satellite data, so that its generalization is there or not. And you can do training on the satellite data and then test on the UAV data. So the models are actually generalized enough to learn what is road and what is not road, irrespective of which data you are using. So these are the kind of a different approaches we have actually compared. So these are the different models. So you can see that UNet++, R2 unit, SE unit, Inception unit, all this model we have trained for our data set. And these are the different already published models are there. So we again took their models and then try to compare results with them. So these are the kind of a comparison. So when you want to publish your paper, you have to do run the same model or multiple models, the same data set, evaluate the performance, and then compare side by side. Then only reviewer would agree. Okay, like Joseph was telling, when you publish something, reviewers would be coming from different background. How do you convince that your work is state of the art, and then whether it is thoroughly reviewed? So this is what you have to do when you write a papers. You have to essentially have a baseline, compare your result with the different baseline, and then report whatever is correct. If you report false also, it's a problem. Sometimes people report over, okay, nobody will run your model, okay, they think, but then people are very clever, they reproduce your work and then they see whether you are really claiming what you got or not, otherwise you have to retract your paper. So many such things are happening. So I think it's good to always be honest with reporting anything in the papers, and that would be also ethical as part of the publication concerns. So this is what we have compared. So these are the different models we have run and then compared on the data set. Okay. And then finally we can see that the comparison, how different models are behaving. Then we extended this our work for the gradient aware directional convolution with the CAN enhanced feature fusion. So we thought the CAN is a very new kind of architecture which works on the you're not training the weights, but rather you are learning the B-spline function. B-splines are the function which is useful in the graphics mostly for fitting different kind of shapes and other things. So people thought, okay, so there's a Arnold theorem for function approximation is there, which says that like there's a universal function approximation in neural network. There's a kernel Arnold theory of function approximation, which says that if you have sufficient number of basis function, you can actually approximate any function with a very high degree accuracy. So that actually we thought we will deploy in our work. And then, so the main contribution of we propose a gradient aware directional convolution layer, which is different from the conventional convolution layer because it combines the horizontal, vertical, and diagonal. Because we are talking about road pixel. Road pixels are not always a straight line; they will be having different kind of a shape and other direction. So we brought in this directional awareness in the our design of the convolution. And then we also develop a dilated residual activation path, which is proposed to efficiently fuse feature from multiple levels within the network. And this module enhances the network's ability to handle roads with a significant morphological variation, such as varying width, complex intersection, occlusion, and other kind of challenges. And then finally, we also integrated this Kolmogorov-Arnold network, which is kind of a feature selection fusion that we call as a CAN FSF. Which kind of enhances the road extraction accuracy by integrating contextual semantic features with the detailed high level of geospatial information. So you see that these are the kind of a challenging roads. So you have different environments. So you can say that shows the variability in the width and shows the case of a vehicle occlusion. Vehicle would be also there. The case with the variability in the colors, and then complex urban environment. So there are satellite images are in different places. If you take geospatial data, all this you have to extract the road. So I will not go into technical details of this thing. This is just a gradient. So we come up with a finding out the different gradients and giving the importance to horizontal, vertical, and diagonal kind of a gradients direction information. And this is the dilated residual activation path for the implementation. If you want to reproduce our work, this you can use. And then this is the Colombo-Arnold network. I will go little bit detail on the CAN actually. So if you just compare CAN and MLP, what you see that in MLP we generally train the weights. We compute the weights, how they would be changing, adjusting for minimizing the overall loss. In the CAN network, we essentially we learn this, the function. So essentially the weights are nothing but the weights over the different basis splines. So you can have splines could be maybe simple, some function, let's say horizontal, vertical lines. These are the basis function, and then you learn how much it's kind of a linear combination of the basis splines, and then you are approximating any kind of a shape. So that's kind of a little different in the training of the MLP and the CAN, and then this CAN actually allows you to have less number of parameters, but then choice of these splines and other things also affect this thing. So that's kind of a very popular model nowadays, and I think if you want to do something changes, you can try this CAN idea in your work as well. So this is what we have done. So we are instead of learning weights, we are learning the functions. These are trainable functions, okay, and then we are getting this output. So, and the idea here is kind of a, they are saying that adding functions is much more easy operation than the multiplying functions. So that's kind of a, you are decomposing as a linear combination of the different basis functions. So it's kind of adding different basis function with certain weights and then getting output generated. So these are the basis splines. So you can learn different weights for different splines, and that's how you can approximate various functions. And then we do actually, we actually done on the 3 benchmark data set, let's say MIT, DG and Chinese data set. And there are different resolution, you can see that there are different sizes. The spatial resolution is also different, 1 meter, 0.5 meter, and these are the number of images, and these are the metric we have used to compare our results. And then we just did the evaluation study. When you want to really publish your work, you have to do, maybe you can come with a very mixed kind of a strategy, but then in the end, the reviewer would want to know which is contributing how much in the overall accuracy. Then you have to do something called evaluation study. So you have to try different kind of a variation and then report again the accuracies in terms of the number crunching, and then you present, okay, these all combination in a systematic way gives the best possible accuracy for the model. Okay. So these are the kind of a, on the same 3 data set, Deep Globe, Chinese data set and the MIT data set we have done. And these are the kind of a result. You can see that these are the road extraction from the different images. So one of the images I'm showing, but there are many images which is there. And then this is the again same thing. Okay. So you can see that how we are able to find roads, but still there are errors. There are still at the intersection, the proper width of the roads, there are many pixels are still misclassified, and then we have to still improve the work. But still, whatever we propose, it's very real time, it's very fast, and it's giving so far the state of the art. And these are the again same result. Okay, and these are the again on UAV data set. So what we have done, we have also done some kind of this particular data set is on UAV, and then this is what we have trained, and then we could get the road pixels. This is the ground truth, this is the predicted cloud set. Because there still some errors are, but these are our Indian data set also you can use for this. So this has led to various publications. So these are the journal publication that student has accepted, and then these are the different conferences that you could publish only in the road extraction. Okay. Now coming to the another topic which I thought I will talk about today is called tracking and now costing of severe convective storms using deep learning models. So the idea here is, this is the work we are doing in collaboration with the ISTRAC Bangalore, And this is the Doppler weather radar. This is called polarimetric Doppler weather radar instrument, which actually kind of is scanning the entire region and then getting the returns from the space. And then if there is a cloud or there are some particles, the returns would be different, and that's basically you use to collect. So radar. Okay, people use radar to even track the aeroplanes, how far one aeroplane is from the other thing, and that's what they use the radar. So radar is a kind of a active element which throws certain electromagnetic spectrum, and then you look for the return, and then you record those things. Okay. So this is called Doppler weather. So many weather stations, many places in India this has been mounted to just watch how sky is, and then use this data to really predict whether convective storm or rain can happen or not, precipitation happening or not. So this is basically nowcasting. So nowcasting is called short-term weather prediction. So it is up to 6 hours, 0 to 6 hours. Beyond that we don't go. So this is kind of the nowcasting. There are different type of forecastings are there. I am basically working on nowcasting. Basically, this project is for the launch vehicle. So whenever we launch spacecraft from the SHAR, so within this 0 to 6 hours we have to find out whether any such a storm going to come or not, so that we can plan our launch timing perfectly, and if there is some kind of a launch disturbance is possible, then we can postpone the launch or prepone the launch based on the weather conditions. That's kind of one of the motivation that ISRO is investing on such kind of a work. And then also people are also using disaster. So you might have seen that suddenly weather would change, and then huge kind of a rain would happen, and then it may cause a lot of casualties. So people are also interested to know such kind of a sudden weather events can be recorded or estimated based on the such kind of a data or not. So these are the two things. So what we are actually interested in also convective storms, which is the small spatial scale. They are for short duration, and the data set mostly is the polarimetric Doppler weather radar. These are the high spatial and temporal resolution data, and then for handling such data, we are using deep learning, which is good to handle such kind of data. I think the ISAR has a data science as well as Earth System Science department, so they can definitely collaborate and then really work on such kind of a problem as well. So what is convective storms? Basically, it is the rapid upward movement of the warm and moist air, formation of the cumulus cloud, and heavy rainfall, thunder, lightning, and sometimes strong winds or hail. And convective storms are typically short-lived but intense and responsible for various weather hazards. So this is the kind of a basic definition of a convective storm. And these are the kind of a process. So from moisture, there is unstable atmosphere, then lifting mechanism, condensation, latent heat release, and then a storm formation would happen in the atmosphere. This kind of a physical process which is happening, that storm would be forming. So we want to do the nowcasting of a convective storm. So convective storm are so frequently occurring events in the atmosphere, and typically accompanied by the intense electrical activity, heavy rain, strong winds, and occasionally hail or tornadoes. And it is also very crucial for the public safety. Timely warning for the lightning, flash flood, strong winds, hail, and tornado would be very useful. In US, actually, if you go, they will always generate a siren if there is a storm coming. So people, they were advised to go into the basement so that nothing gets affected. And transportation, like real-time information for rerouting, delays and cancellation, emergency response. Now recently you might have heard that Bombay-Pune highway was blocked because of one accident. So everybody is stranded there for 18 hours. People are going now by flight or aircraft or helicopter. So such kind of a even intense weather thing can also disrupt the transportation as well. And infrastructure protection, economic. So there are many such impacts are there for weather custom. So what is the challenge? Our objective is to develop a convective storm nowcasting and classification algorithm based on the deep learning techniques using the data from India polarimetric weather radar data and other in situ observation. And the goal is to develop a system for nowcasting convective storm using the Indian radar data. What are the challenges? Lack of the labeled data. So we are collecting this data from the weather radar, labeling them, and also taking the data from a ERA 5 website, and then also labeling them and then utilizing them for doing the prediction. So what we are doing, we are first doing the time series prediction with the deep learning. So it's a time series problem because we are recording every 1 hour scans. This is kind of a scanning the every now and then we are getting this data, and then we are feeding that to model to do a time series kind of a prediction, and then train a deep learning model to predict the radar data at a future time t plus delta t. So if I have a time t at time t, what would be the weather at t plus delta t? That t plus delta t could be 1 hour, 20 minutes, 6 hours, whatever. And also then train a classifier to identify what kind of a convective storm it is there, so that we can predict it well. So this is the typical architecture. So we give this radar data, which is mostly horizontal reflectivity. I told you that radar data is a reflection. So basically we send something and then get a return. So how does it, different reflectivities are changing. So it's called measured in the dBs. And then we are also using this data from a ERA5, which is a European agency has developed a recording all the atmospheric conditions at different locations in the world, and they populate those data in their website, so you can pull the data and then utilize for your application. So, and then since radar data is very collected in the instrument, it may have a noise, and then from there we generate the PPI plot, and then we use the spatio-temporal interpolation from the ERA5, because these are the two different time instants. One is coming at, let's say, 1 hour, other is coming at 6 hours. So how do you fill in the gap? That is the basic idea. And then combine these two things, radar prediction module, and then classification, then basically doing some kind of a nowcasting of a convective storm. So this is the our study area. So we are using this TULS. If you know the TULS, it is the place in the Tumba where it's called Tumba Equatorial Launch Place, which is where this radar is located. So we are getting this data from a polarimetric Doppler weather data, and then this is the ERA5, which is also having these recordings from the satellite, and this is basically used for PPI images. And what we do basically, this radar data is downloaded from the visualized PPI. So basically there is a modus, MODIS is there. So MODIS is actually holding all this radar information. So there is a portal, you can go there and download the data, which suppose you are studying Vidura, so there is a data for Vidura. Wherever it is located, there is a range for each weather radar data. In that 300 to 200 kilometer or meter range, they can actually give the data. If you don't have radar, then you have to establish the radar, which is kind of very expensive. We don't have much company who can develop radar and then weather radar kind of. That's another area. So that basically radar data we get, and then plot this. So this is the PPI plot, which looks like how the returns from the atmosphere are coming in the 360-degree at different sweeping angles. So what we do is called the radio frequency interference classification and mitigation in the C-band. C-band is the 4 to 8 gigahertz frequency, and this is the Doppler weather radar. This is the CNN, DN, CNN approach we have used. And this is the CNN model has been used for RFI, radio frequency interference classification, and this DN, CNN model used for RFI mitigation. And the objective is to classify RFI signature in PPI reflectivity in the Doppler weather radar using the CNN model, and also to mitigate the interference due to the other electromagnetic interference. So what we have found that the CNN model is well able to classify RFI at various locations in the radar data and obtained around 96% accuracy, and then this model is also able to remove those interference, and then we can use it for different applications. So these are the RFI classification. We have done non-RFI, and so wherever the interference are affected by radio frequency interference and where it is not affected, that is the classification. And then mitigation, we are kind of removing those artifacts. If these are the artifacts has to be removed, then only you can utilize for better classification. And then we are, this is the clean image, this is the denoised image, and then we are trying to see how much is the difference between these two. So once it is the clean data, any model would give the better result. Otherwise, this interference can change your interpretation. So this is the ERA5 also pre-processing. So if you just see the temporal interpretation, the radar basically has available every 10 minutes. And then this ERA5 is basically is not as accurate. Kind of there is a difference in the temporal interval that actually one can record. So basically this is ERA5 is hourly, and this is the radar is every 10 minutes. So how do you basically develop an interpolation method to have signals at every 10 minutes in the ERA5? This kind of interpolation method also you have to develop. And then this is the nowcasting methods we have actually developed. I have to go to the, so this is we call as a RES. So we are using this residual learning, then squeeze and excitation model, then conv LSTM for time series prediction. So that's what we call RES-SE conv LSTM model to do this nowcasting. This is our overall model. You can see that we are inputting this PPI image and the era 5 data, and then finally generating the kind of at time t. If this is the image, what would be at time t plus delta t? What would be the image? So what we found that we got improved gradient flow and learning stability via residual connection, and enhance the sensitivity to convective storm structure through the channel by attention, and we have improved the prediction quality, especially for longer lead times. Okay, I will just do it. Okay. So I will just skip some of these slides, and I will talk about another work that whether nowcasting works. So this is the another this LSTM former also we have developed, where we are giving this input data as input to the model, and then trying to predict in the time t plus delta t what would be the values of the different modules, and then we can predict the nowcasting. These are the results. And this is another thunderstorm classification. Again, we are using deep learning models for thunderstorm classification. And these are the kind of real world data you can use. And these are the, again classification, the different kind of classification we are doing for thunderstorm. Okay, so these are the again publication out of the different works. These are the work done by a PhD student. Just to conclude, so AI can be very useful in many places, including urban planning and weather nowcasting. Okay. And this CAN is also very good architecture you should utilize for, suppose you are doing some function mapping and function approximation kind of a thing, or in medical imaging, CAN could be very useful. And then using these models for societal use is the one of the motivation that we have in our lab. So we are using for urban planning as well as for weather forecasting, because we are also part of ISRO, so we are also contributing in their workflow as well. And I think harnessing this radar data for weather nowcasting very useful. It can be very useful in disaster prediction and modeling. So I think you have got now various domain about the how AI same tool can be utilized for different application. Now it's up to you how you choose your problem of interest and then apply for broader goals and broader objectives. So thank you very much for the opportunity.
Thank you, Dr. Mishra. Any questions? Any quick questions? Yes.
Thank you so much, sir, for the really insightful talk. So what I could understand from the first work was the main benefit of using CAN was the better feature learning from the road network as a network of curves. So can we use the same approach in weather nowcasting?
Yeah, so CAN is very good at fitting the functions, these spline functions. So suppose you are essentially interested in getting trajectories or some kind of a shapes. I think CAN would be really useful. Nevertheless, it is a function approximation method. So if you want to predict, so you are saying that the output, let's say temperature of certain things, is function of various combination of other functions. Definitely you can use CAN, but it is more useful where you are essentially looking for the complicated shape and trajectories, where you really want to, let's say, in arteries or some kind of a road network, rivers. So those kind of places where you have sudden change in the attribute, because in general what we assume that things would go straight, but whenever sudden change happens, this function could be very well fit and then can be utilized. But we have not used in the weather forecasting, but definitely if it is a model for function learning, one can attempt that.
Please ask more questions during the lunch.
Thank you very much.
Dr. Priyanka, may I request you to hand over the microphone. So students from the ISET TVM, I think your mess is about to close. So please head to your mess. Students coming from the outside, you have your food coupons with you. So let's regroup in the entrance of PSB for a short photo, for a quick photo session. Yeah, this. So the internal students, please head to your mess. You don't need to wait for the photo.
It's not a very poor organization, I agree with it. Is it a happy birthday? I don't know what these guys are doing, man. I mean, to be fair, it all started because the bus got late initially. So everything would be.
We have already met our respected guests. They will now join us in the panel discussion. So please join me in welcoming Dr. Kesav Das, Dr. Joseph, and Dr. Deepak Mishra. Representing School of Data Science, IJ Thiruvananthapuram, we will have Dr. Saptarshi Bej. As a moderator, we have Dr. Laltu. Yes, so we will now start the panel discussion. At the end of the discussion, we'll open the stage to the audience to ask questions. Please be ready with the questions so we can have a smooth progress immediately after discussion to some interesting questions. Laltu?
I think my mic is working. Okay, the thing that is that I am the only person in our data science group who is not working in AI agility.
Okay.
Is it audible now? Okay. So I am the only person in our data science group who is not actually working in data science, in cryptography, and that's why I think I am the right person to ask questions to the persons who are working in AI/ML, who are in experts, but the students are not. Okay, so but the question is, the thing is that I prepared some questions for them, but most of the questions already answered by Professor Kesav Das during his talk, but still I will try to make some questions to them. So first questions that I want to ask Professor Mishra. So now AI is getting a lot of knowledge from different sources, and it has a lot of knowledge. Now, how in the present scenario, the AI, how it is solving the hard problems in our society?
Thank you very much for the opportunity and very excellent question. So AI is solving so many problems. Now we see at least students' problems are already solved now. All the assignment they can do very easily, programming assignment, all those things they can do very fast. That is one part of it. But coming to the social part of it and the actual part, so what you see now that most of the work is happening on the foundation models. So now people talking about foundation model for the weather, foundation models for the atmospheric science, foundation model for the medical imaging. So now I think the study or the procedure or the basically orientation is to develop big foundation model for societal application. Let's say we wrote one project with ANRF on basically water quality assessment. So now you can actually give a lot of parameters and measurements, in situ measurement, and then that can be utilized to check the water quality from satellite data, and then you can tell, okay, this is going to be extinct in after 10 years, or what, some pollution it is coming, or some waste is coming in a particular way. So now this clubbing of AI with the data which is coming from different sensors is actually helping us to take a real-time decision, which was kind of ignored. Recently we heard about in Indore there's a water pollution was happening, and that a lot of people died because of mixing of two things. So I think such kind of errors, so we need very good infrastructure. So we are just starting, but nevertheless I think we are in right track. I think this India AI mission is essentially focusing on using this AI for societal application. And I think students like these and faculty and colleagues like us, we have to really work together along with the government and develop these new avenues and then really develop a use case for Indian subcontinent. Right now it's all for Western world. So now I think it's our responsibility to use our knowledge and develop things for India. That's what I personally feel.
Thank you, Professor, for your good answer. So you started with saying that students are they are solving their assignments using AI. Now I am passing a questions to Dr. Joseph that people are starting to apply AI tools in everything. Now students tasks are getting easier for the people, and for company also tasks are getting easier. So they are like getting a multiplexer kind of things when they are getting very fast. So how the new generation or how the company is getting advantage from this fast process?
Yeah, research, I mean earlier maybe 2 or 3 years before we used to say, hey, let's say a paper is published 2 years before it's pretty old, but now it's like if a paper is 1 month old, it's actually stale. So that is the progress that is indeed happening in the space at this point. It's frightening for a reason, because like you don't have time to sit back, relax, and then plan for the next big thing. But it's all about instantaneous, and then be prepared for that. And so the change is there definitely, and it will only be much more faster. Whatever be the change, I believe that there will be a lot of fundamental things which will remain open. For instance, LLMs and multimodal LLMs and whatnot, they can indeed create code for creating web pages and so on and so forth. And it's like, I was just speaking with a few others during lunch too, like they can actually create web pages like as if it is a pro web designer. And this is only going to increase. But what if the output that gets generated, we don't know whether that is aligning with the user's input. So so how do you enforce guardrails? And going to Professor's talk on medical side, where this will get even more important, where let's say if the model is diagnosing something and giving an output, how confident is the model is, and then how much is that confidence aligning with maybe a professional doctor with years of experience, how much is the alignment, and is it safe to act upon a feedback from the model and whatnot. I think these are open questions. And that's the reason where even for big companies like OpenAI, there's a huge team on alignment, or rather figuring out how good the model is and so on and so forth. That's an open space. Now, this level of research, let's say you plan for something and then you spend your sweet time getting your method, getting your results and whatnot, to really coming up with new problems that are indeed not present at this point, but is there within a few weeks or months from now. Getting that insight and then working upon that would be more easier path forward, at least for a researcher.
Thank you for Dr. Joseph for his good answer. And he mentioned that the thing is already we are working on medical data kind of things. Now for medical data, we can say for doctors. Okay, so they also try to use, not trying, they are using medical data, and they are using AI-enabled tools for their results, what are the testing. Now, people in the society, they are considering that why AI-ML should not be a second opinion. Okay, so doctor, may not believe the doctor blindly. We can we want a second opinion from AI. So what is the present status of that? So in your experience, what the patient you are getting, so what is the status of that? What people are saying, that do we want this kind of things, or what with respect to you, that will you use that for now, or it's still under very basic stage?
Very practical question, because this is something we are already facing. Patients who are coming to the OP outpatient clinic, they actually come up with a lot of questions. Suppose I have diagnosed a particular disease, and then I have to explain to the patient, and you have gone back home and looked at the AI and the management of all these things, you have learned yourself, and then you have come to the doctor, and then in the second visit, the doctor is asked, doctor, can't you do these things? Now there is an issue there. You see, there is, first of all, as you all know, everybody in this hall, there is the ego of the doctor. I have learned 5 years, plus I have learned specialized, and I have worked so many years, and then this person is coming in and asking me such questions. So that ego is always there. So we have to be careful. Not all doctors will take it in the very same way. But it has become essential that every doctor, today I was discussing this with your director also, it is essential that we have to still answer to the question. We have to be more patient. The patients, and we have to tell that yes, these are the things what the AI tool is telling. Their decision making tool has some points, but in your case, this is the way it has to be done. And I have discussed with my team here, and the team here thinks that in your particular case, this is the. So ultimately, there is something called the faith in the doctor. Today, even today in India, most of the treatment is based on the faith, and the faith is actually by this human interaction, which has not happened with AI. That we have to realize that. You see that even in the bank, the bank has, if you go, everything has not become automated. Still people want to go to the bank, talk to the person there, the staff there, and get that information, because that is the faith between. So the same thing is there in the medical field. That faith is the most important thing, and that drives the treatment. And therefore it has become the responsibility of the doctor that he knows AI, believes AI, tells that whatever you have learned is not wrong, it is correct. But in your case, I have evaluated the case this much, and these are the problems that I am seeing in the AI. This would be a better treatment for you. So there is a second opinion. Even without AI itself, people go for a second opinion. They can go to another doctor. So the AI is another opinion, that's all. So you have to balance and tell the patients that nowadays patients have started believing. The only issue here is government hospitals, where there are about 100 patients waiting or 50 patients waiting to see you. You have no time to explain to the patients. But if you go to a private hospital where there are lesser number of patients, you have time. So this is a problem that we are facing, that most of the government doctors are facing that issue.
Thank you, Professor, for this wonderful point of view on this comment. Now, I think I also believe in the same, where the trust is a very important issue in medical. So now I am going to ask another questions to Dr. Saptarshi. That students are different questions. The students are using now AI tools and LLMs to solve their assignments. Okay, mainly for small projects, they are trying to use them. Now, so in future, what is our thinking that whether it will make problematic for them for their critical thinking? Will their thinking directions will be some corrupted, and now it will be difficult from their future large projects. So will there be problematic for them, or they will be adaptive and now they can build good projects. So what is your opinion?
So I think this question is sort of the teaching equivalent of what you asked Professor Kesavadasa. So basically, that is a question for doctors, and this is sort of what I found funny in Professor Kesavadasa's answer is that he said that doctors have to be patient. So it's like AI has driven doctors to be patients. So
to learn patience.
Yeah, so I think teachers also have to be very patient about this thing in sense to learn patience essentially. So the thing is that in terms of giving assignments and evaluating assignments, I'm actually fine with people using AI. So what I think is that I always say that while using AI, it is better to see you as an adversary of AI. as if you are put yourself in a position. So we have to learn to live with AI. As instructors also, you have to learn instructing using AI. You have to take it as a fact that students are going to be using AI. I would, when I use AI in my research, in my teaching, I use AI as an adversary. I put myself in the position of an adversary, in the sense that I use ChatGPT, let's say, but whatever ChatGPT says, I try to read it and understand it to the deepest level, and then if I find contradictions, I challenge it. So if what the problem is that people are expecting that we are getting habituated to these easy way outs, and we are giving answers, we are giving questions, and we are expecting a perfect answer from the AI. That is not happening. It is not immediately a perfect answer, but through prompts and all, you can make it perfect. But to give those prompts, you have to understand the science, right? So you have to drive AI towards a good direction, so that it helps you. It's not a solution provider. AI should not be seen as a solution provider. It should be seen as a companion who would help you improve things, and that can happen only if you put yourself as an adversary to the AI. You challenge the AI basically and enforce it to give better and better answers.
Thank you, Dr. Saptarshi, for this good answer. Now I am passing the same questions, almost same question. So both Professor Keshav Das and Mr. Mundar are teaching for long. So they are also experiencing the new students, as there are generation gaps over there. So are you facing this kind of challenges in your place, that the students are copying, they are not copying, they are doing assignments from AI tools. So what your observation for long term, because we are very new teachers, so what's your experience? So
yeah, so my question, I can answer it quite in a simple way, because our students are not technical students, they are technically weak. Medical students are basically technically weak. Their implementation of AI is slow. If you take 100 students, the implementation among medical students is lesser. Even now, they believe the conventional systems and they are going by the conventional. Few of them who are taking up these things, especially in diagnosis of the disease or writing a research article and all, they are afraid that they will be caught. So they are very careful, they don't use it. That is what I have seen. Most of them don't use it, or if they use, they declare that I have used this AI tool for writing the thesis right away. So in most of the research also, their applying that is very less. So I think that in this connection, it is important that for the medical students, more AI learning is needed, which is very less. At the same time, in my first question that you asked, I told you, it is very important that they understand about AI when this comes. So several organizations like National Board of Examination, IIIT Hyderabad, and today I heard IAST is taking this effort to teach the doctors in public health and hospitals AI methods, and it is essential, because then the method they practice, the method they do research and teaching, everything will improve. That's what I think as far as the medical science.
So I want your review on
So I actually completely agree with all the speakers. So I will tell you my experience. I am facing day-to-day life these things actually, because I am associate editor of one journal, and we always get a complaint that references are non-existent. People are keeping those references and they are not, doesn't exist. Several such complaints come, and then we have to deal with those things. That's anyway high level. Regarding students, one thing I observe that if you see the education transformation in India, earlier the good education was only available at IITs. Then NITs came. Then a lot of private universities are coming. Now you see that this NPTEL, Coursera, so many online materials are there, and that actually has enabled people from a rural India, if he has internet, and is willing to learn something, he can learn state-of-the-art things from a state-of-the-art university, from a state-of-the-art professor. So there is no such foundation of learning no longer that the skill set only live with the IIT people. Although they are very bright, they are top 100 people or 200 people from entire country. But so that has now, so now this AI is another entry into this thing. Now if I don't understand a concept, faculties are available, let's say 9 to 5. After that they go, and then you cannot find time for the faculty, okay, are you available to clear my doubts? So if you just see as a positive aspect of AI, at least some of the rudimentary confusion and question that students have, now they can at least ask this question to AI, and then pretty much you can believe they are correct because they are improving over time. But then it's kind of a assistance to the student. They are actually helping it to learn things in a much more better way. There's a side effect of it. Too much reliance on anything is also problematic. Suppose you only say write SOP for me, write email for me, then you will forget. You know, people are now forgetting to write. Mostly they type. So it's like if you don't use your skill set, you will lose that skill. So I think it's our responsibility being a faculty to be able to challenge the student in much more better way. Maybe you should ask this question, okay, you give the prompts when you submit an assignment, what prompts you have given, analyze their prompts, and also give the question which is cannot be solved by ChatGPT. If it can be solved by, so it's like we have to also learn how to ask better questions. So it's like a both ways, problem. But I think in a long run, if you see that AI would thrive, but then in the end there are limitations of AI. They are not human. So we can ask questions in a much more defined way. We can also have emotional aspect. We can also integrate the background of the person. So it's like not a one-way communication box. So faculty, AI, student, I think this combination would finally useful for the better learning outcome of the student. So in learning point of view, I think introduction of prompt engineering is something we have to do. As your lecturer also mentioned that AI would be taught as a foundational level course in all possible aspects. So we cannot go away from that.
Thank you, Dr. Mr. For his wonderful answer. I have noted 2 points, and one of them is that we should have to adapt as a faculty. We have to adapt. But now for the students, what message goes that they will also adapt to use, but so as he mentioned that we cannot overuse it. We cannot be dependent on it. Okay, so anything which is more than need, it's like it's a bad thing for us. So next questions that I want to ask to Dr. Joseph. So what is the Dr. Joseph? So what is the present day state of the art things that theoreticians already done? Theoretically they are, but what is the practical of it? Means what is the implementation? Like theory it is done and practical. So what is the
Theory
state
of what?
Huh?
What theory are you
So AI/ML theory, some theory has been done, maybe. Okay, so what is the level of implementation till now?
Sorry, I didn't get your question. Can you clarify a little?
Okay, so
yeah, that's I think pretty vague question, but still let me try to take it.
Okay.
So theory and development, I think both of them should go hand in hand. I mean, if there's a theoretician who's just working on equations and numbers and not necessarily proving theorems and whatnot without any grounding on how that is actually going to be implemented, that doesn't validate the theory. At the same time, if there's a practical guy who just does things like changing your learning rate, optimize or blah blah, changing hyperparameters and getting things done, that without any kind of theoretical parts, it will also not lead anywhere. So I think there should definitely be a coupling between maybe the theory and the practice. And in AI, I believe in most cases, theory tries to catch up with the outputs. I mean, for instance, if you think about it, GAN or generative adversarial networks, the idea that you will have a model known as generator and then another model known as discriminator, that actually, when let's say Ian Goodfellow, who came up with GAN, this was a bar conversation that he had with his friend. So, and then they came out and then just implemented it, and they had good results. And then they had to go back and then dig up theory to support this. So in most cases, I mean, like AI has gone through this in quite a lot of episodes, and then the same might come here too. Like even for AI, I think, see, I mean, at least for a researcher, nothing is new. I mean, we have had LLMs for a long time. We have had these models generating images, text, and whatnot. This has been out forever. But what has changed is maybe, I mean, like, okay, another thing, like when most of us refer to AI, we are referring to maybe ChatGPT. But think of it as just one company and one product that we are referring to as broadly as AI. There's something more deeper there. So it's just that the scale that they had with the compute, the data, we don't know how they got it, but still, I mean, like there's a lot of things there underneath, right? So I think when theory, practice, I think it should go hand in hand.
Okay, so answer is very good. I was not present the questions correctly. I think the question should be that is there any gap? And now from his answer, there is no gap. They are going parallel.
I'm not saying there's no gap. There's definitely gap. But the thing is, like, one is like it might not be possible to even understand the gap, right? I mean, so I mean, there's a lot of things that actually work perfectly. The theoretical underpinnings for that might be weak. Likewise, something that has strong theory behind that, we will not work it out. So there's definitely a gap, and it's about maintaining the balance between both.
Thank you. So now I will again pass questions to Professor Keshav Das. That now AI ML tools we are building. So you are also doing research, and they tool are giving results, outputs, and in there. We have to assume sometimes that it's giving the result, but how it's giving we don't know. So it's a kind of black box to us. So as a doctor who don't have, as per you, don't have much technical knowledge on that, you are assuming also black box things. So how you are considering this result in your treatment or your diagnosis?
Very valid question, that one, because this is something which is written in most of, whenever you read a chapter on AI in medicine, this part is always referred to, because what is really happening, this black box part is told, and the output what comes, they always say that we do not know whether it is correct or not, whether how it was obtained or not. And in field like medicine, it is extremely important that everything is explainable. So explainable AI and explainable AI methods are now coming up, and if you see the present research which is going on is more on that direction, and you have to have some way to explain what is really going and your output part is correct. So I think there was a period where there was this black box, and people have actually now putting it down. I'm very sure that this explainable AI methods are going to come, especially in medicine. This is very important.
Thank you. Now I have a generic question.
Yeah, I'll just add to it because I think it's a panel discussion, so we should discuss too. So I believe that's very true. Explainable AI is a very hot area, and even for the state-of-the-art LLMs and multimodal LLMs, one key area where people are interested in is like, what is eternal? And what if you tweak some part of these models, how will it behave? And I'm very sure, specifically medical and for many other fields also, there should be a repeatability. And there should be, we should definitely have some kind of a, let's say, not theoretical at least, but sort of grounding on why model is telling a specific answer and so on. Hot research area.
Yeah, it's a hot research area.
The thing in the same context, we can say that since we know that some black box are there, and in some cases it's really since explainability is coming, the amount of black box, maybe the volume of the black box, we can say it's sinking. Now we are trying to using AI in different places and like monitoring things and different places. So. But the question is, there is no accountability as I know. So what is your point of view on that accountability? So when we are using AI in some specific task, where there is some automation. So what is about the accountability?
Should I?
Yes, yes.
So during the lunch, actually, Dr.
You
Deepak,
mentioned this.
yeah, Dr. Deepak asked me this question. I think, yeah. So now suppose Dr. Deepak or someone from the audience, somebody asked me this particular question. That suppose in that BPL this thing, you asked this question. Is it gives a result and it is wrong. It's a possibility, you know. So who takes the liability of that? So it's a very, again, for medical it is important. So presently what the doctors are doing is they take that information and then recheck what is there. It gives, it may be false positive, it may be wrong, but still the doctor will take that information as an important information, check it again and find out whether what has been done, the result obtained by the AI method, whether it is correct or not. So that possibility is given. Sometimes it becomes wrong, but at least there are methods by which now you can send this image to the doctor's home. The doctor, it may be a midnight call and it can be rechecked. So if this particular AI method is telling that this is a very emergency situation, then immediately it is sent there and the doctor rechecks and then finalizes that yes, this is an emergency, I have to go to the hospital immediately. So there is always a rechecking. You are not completely believing on these AI tools. This is the present state in most of the AI tools. You do not completely believe it. That is a positive thing. I think that will go on for some more time before the doctors have faith in AI.
Thank you for your answer. I think students also always keep in mind that we cannot believe AI blindly. So my next question is a little bit different. So India now, the rich country like USA, Japan, China, they are spending a lot in research and development and including AI, so total research and development, almost 3 to 4% of their GDP, where India as a not that much rich country only spending 0.65% of their GDP in research and development. So and they are distributing this fund to different universities, institutes. Now in the institute scenario, how the present researchers are taking this as challenge and developing AI tools or doing the research in direction. So what was that challenge? How they are going ahead and challenging the world? So in the present scenario. So this question I will pass to both of you professors. Okay,
so I would say that India is well known for generating good, intellectuals. If you find all AI researcher, including honor of CEO of Microsoft and Google, are Indians actually. So it's not that we don't have knowledge. I think you're talking about resources. So now I think there is a lot of reforms are happening now. There are India AI mission, quantum mission, monsoon mission. So many missions have been started. I think government also understood that we have to focus on one particular semiconductor technology like that. Some verticals has to be identified and then money has to be distributed in those directions. Now it's up to the researcher or how to establish collaborations, how to prepare new generation for taking up newer technology, because we are working in the era where a lot of restrictions have been imposed by Western world on us. You will not be getting the technology that you want immediately. And we are always, I think, 30-40 years behind all these bigger countries. So I think now it's the time that we should really solve Indian problem rather than solving Western problem. We are always using Western data to compare our results. I think it's the high time that we start labeling our own data set, start collecting, giving it public forum, and then give reward for doing those work. That's like now various hackathons and various event like this event has been sponsored. So a lot of students from India could participate in this. So I think this is the now opportunity for us. Maybe 5 years down the line, if you continue doing this thing, we would be also technically ahead of many other countries. Although catching up US will take still time, but I think once we really niche into something, let's say suppose we develop good algorithms or good hardware, more investment would come from foreign companies and we might be having a good infrastructure. So I think it's the positive attitude we have to keep towards the our youth, and then only we can create a better country for them. But they should have a good opportunities. They should not be looking job elsewhere, but they should have it in India. So I think it's the faculties and a startup's responsibility to invest money which is earned from India to the India growth. I think that's I think we should do. And I think sharing our knowledge with all others, collaborating with even private university, and not only with only government institution. I think we have to have good ecosystem where knowledge should not be bounded within few boundaries. So that I think has to happen.
Thank you. Keshav Das, will you?
Yeah, so as far as I will tell mainly on the biomedical side. So the one of the main issues that we are facing in the biomedical side is the data privacy. And you know that unlike the many other areas, the data privacy is always a problem. There is a new DP rule which has come up, which has been passed in the parliament. And even now, that finalization of that being a rule has not come up. So how will you use? Should you take consent from all the patients whose data is going to be included, or it is only for patients who are you are going to do prospectively, not the retrospectively? Your model creation and all can be done on the data which is already obtained on a retrospective manner. That means already available with you. So these concerns about data privacy is there, which is actually not very encouraging in the Indian environment. We have to have rules framed very fast by which we will be allowed more to use. So the DBT, ICMR and us are now coming with policies by which you can, whenever they give funding for a data, this data should be publicly available. If it is publicly available, I can use it in the, even after that the data will be there, another institution can also use it. So take you are going to do a study on dementia. One study has been done in one medical institution in Bangalore. I should be also able to use it because it is with the hospital funding that data has been acquired. So such policies have to be made. We somewhere lack on this fast policy making, and that is actually slightly slowing our process in the biomedical imaging side. The second point is many of the academic institutions, when they start, we work independently. The medical institution, the engineering institution, the collaboration is not there. So some of the times when the engineers or the scientists start working on this, these are some of the areas which have no actually clinical relevance. So there has to be very strong collaboration, frequent discussion between the clinical group and that means the users as well as the people who are actually making it. That is, and the third point is most important, and that is what I feel, is get involved the industry very early. As soon as you are coming up with some good results, and this happened for us because somewhere in 2019 we started a work on stroke detection, which I showed you. Stroke detection and early stroke detection is the work which we were doing using CT images. One company actually came forward. We were very thrilled that they came forward so easily, but then they the work did not go ahead. But the problem there was as soon as the industry went down, the whole interest in the project went down, and we did not go forward because they were funding it in the initial period in the particular project. So industry involvement here has to be early. They also look at the possibilities of multi-center trials and all these things. So combination of all these three, academia, both from the medical side, engineering side, and the industry is needed for biomedical AI development. That's what I think.
Thank you, Dr. Professor Keshav Das. So now I have a question to Dr. Joseph, that we are now seeing the news in various news channels that due to AI, companies are firing their employees. Okay, so there is a job crisis kind of things. Everything we are just to, it's coming news. So you are in a company and you are also hire people. So as a student, what students should think of it? Will they fear about it? That's job are reducing due to AI, or they will be hopeful for best thing.
So AI is disruptive for sure, and with a good amount of certainty, I can say that software engineering, web development, and so on and so forth will be taken over by AI. Like in your slide, it was 2027 or 2028, but I think much more sooner than that. So that's a fact, and I think we should acknowledge that and then move a plan for that. So it doesn't mean that we should not learn the basics of coding or whatnot. That is definitely there, but we should definitely plan to embrace AI. Use that in ways that can help with their profile building, and then of course, jobs being fired and whatnot. Of course, that's a cycle. There's no definitive answer of that, but when computers came, everyone told all the blue collar works will be gone off, but that hasn't happened, right? So all of them got embraced, and they started working on something else that is more productive. So I think AI has the power, and mundane things like standard software engineering, software development, web development, mobile app generation. We have to think beyond that and think about, let's say, much more harder problems which we are intimidated to solve now, which we should aim for that. And then while we solve that, AI will just become a tool towards solving that. So I think that change of mindset should happen. And then definitely the next set of, let's say, jobs might also revolve around that. So I was listening to some other podcast the other day, an experienced guy was kind of saying that no one can guarantee something like a 9-to-5 job, or one job where you'll be attached to an institute for 30-20 years. That's definitely not going to happen in the next maybe 10-20 years. I think people will get more skilled people, will get more skilled AI agents to do things. Now it's about embracing that towards solving much more harder problems which we cannot solve at this point.
Thank you. So next is we want to take some questions from the audience, from the students. So any questions from the students? Okay, so many questions. So is there a mic? Okay.
First of all, thank you for this opportunity. We have already faced 2 AI winters. So what are can you hear me? We have already faced 2 AI winters. So according to, based on current scenarios on funding for AI research and competition in the job market, what are the chances for another or a third AI winter?
Winters will come, and after that summers will definitely be there. We cannot sustain with that, just the winters. So I think it's related to the last question that he had to. It's all about upskilling and then embracing the technology, and then I think we should always be optimistic that it's not that someone is going to take away the jobs, but it's more like these tools will let you kind of do things much more effectively in ways that you could not even imagine a few years before.
So I would like to answer this question. See, nowadays people should not be looking for a job, but rather creating jobs. So I think you should be thinking of, see, if you just take country like India, or if state like Kerala, there are many problems still there. There is no solution for it. There are a lot of still people have to wait for appointments, getting, train tickets, bus tickets. So many unorganized sectors are there. You think about how you can utilize these tools for improving those sectors. That would make a startup, and then you can start creating. It's not that AI has solved everything. Okay, when this started. So I think you have to look around and find the problems in and around, and then see whether think through whether can I collaborate with somebody, or I can take mentorship from someone, and then solve this problem for some local people. Even in education, you can make apps to learn different learning abilities people. So I think it's just our mindset. If you only want to work with Google, Microsoft, Samsung, then it's a crisis. But if you want to really do something niche and you want to develop something out of the box, like how US people have done, like all this startup have come out of this some discussions only. So I think that is where now our youth should think of, how small ideas can turn into a unicorn kind of a thing. But yeah, it's a risk-taking thing, so you should be ready enough to take risk. Maybe you should have support from government for your startup. I think those policy decision also can be taken. I think, but in the end, it's your effort how you use this technology for solving the real-world problem. And once you solve it, you have a market.
I think he's got answer. Next students.
Thank you, sir. And I would like to just a common question to everyone. As Deepak sir has told earlier, that there are references being made up by different GPT models and other things, and there have been instances where the newspaper news they have made the news. The structure, I think, the grammar, I think they have been looking at, and at the end they have like the newspaper, it has been printed like, if you want this one, I can even make that. So the GPT model, those answer has been copied. So AI is being used in education, healthcare, information technology, home automation, transportation, every field. And in every field, like data is being used, and Keshava sir has told there are sensitive data being handled, and there is accountability as far as the implementation is and usage is concerned, and proprietary ideas are also there when the companies are using the AI model. So where is the opportunities for building a framework for development, testing, implementation, as well as usage of AI in different sectors? Like, is there any window for researchers as well as students to contribute to that, for developing a benchmark standards for developing the benchmark standards for AI in the development, testing, implementation, and usage of AI models in each sector?
So I would like to answer. So let's say if you say there are space missions, let's say there is a lot of challenges hosted by Department of Space recently, where they have given, let's say, problem like fire means wildfire detection. How does fire spread in a different place? Then crowd estimation, building GIS maps from the satellite. So I think if you see different government agency, let's say like DARPA in US, the military academy and Navy and Air Force together, they are also hosting a lot of challenges where they are actually giving problem statement to the public, and then you can participate through collaboration or through any other thing. I think now you have to really look into the different government agencies, and then they are coming up with the real world challenges with a reward. It's not that you have to only develop something. If you are really clever, they will invite you, they will fund your startup. So I think there is an opportunity. Regarding framework, I think mostly as such now there is a GPU scarcity was earlier was a problem, that you don't have GPUs in all possible private institution and small level government institution. But now India AI mission has come up with a plans for GPU, so you can rent it out. So if you have money, hourly basis or use case basis, you can actually take the cluster and GPU, whatever you want, cloud services, and develop your algorithm and then do a prototyping. So I think infrastructure wise now it is improved. I don't say it's perfect, but nevertheless it's not like collab, like you have to buy professional license and then they will not allow you to upload more than this data set. So now I think you can hire. If you have money, it's not very expensive. You can develop and prototype and then get your result. So problems also, agriculture has a problem, forest has a problem, water. I think you have to talk to different ministries, come up with your ideas, and then they will definitely fund you. Although this process is not that fast, you need to have connection. So I think the forum like this would really give you a chance to connect with different people, and through that mentoring and connection, you can reach to the question that you are really on to answer. That's my view on this.
No, as far as the biomedical imaging data, what you told is correct, that there is too much of importance on data privacy and all. So now one of the faculty from ICER was discussing about federated AI systems, where the model is given to the institution, where the training data, the validation data, and the test data, everything can be tried at each of these centers separately without actually sharing the data to a central node. So it is when you start sharing the data between these various institutions, then it creates the problem. So people are now coming up with some structures by which you can keep the data yourself, that institution itself, but the model can be used and its validation can be done. So newer and newer methods are coming up on that area by which you can be safe about your data.
Anyone else? Any question? Go ahead.
Thank you for giving this opportunity. As every student, I am also confused. Even looking at the current job requirements, and I upskill according to that. Even the job trends change within months. So this is my concern. And the question is that, will AI create more jobs than it eliminates?
Yeah, so I think Joseph already talked about this. So see, the thing is that these things evolve a lot. Yeah, I'm confident that AI will create more jobs than it eliminates. So there is no question about it. So the same question was there when computers came into being. People were talking about. So let's say as designs are, so Dr. Joseph talked about these different designs of posters, for example, right? So it might be so that at some point the creativity of AI might also be what you call boring, right? So as long as we keep on providing data, AI will learn to generate new things, right? And if that is stopped, right? Suppose you have some AI which you trained to do something and you don't update it at all, so it stops at a point, right? Then things will not evolve, right? So you imagine that how much graphics and all these things, even the sense of designing, that designs that has making slides and presentations, how much that has evolved in 10 years, right? When PowerPoint came up, we were so proud to have these word arts and all different types of animations and all in our presentations, and now people really like these sleek designs and Gen Z style fonts and all these things, right? So these things are sort of the creativity of AI, the sort of variability that it keeps on producing. That also depends on how much data is getting fed into it, how much data is getting generated, and human creativity will always have to support the creativity of AI. That's what I believe. If humans stop creating, AI will also stop learning, right? So AI is learning because of human creativity. So I believe that that even if AI, let's say web designing and also, I'm sure that new paradigms will also come into being, right? Which AI has to learn again, right? So I don't think that this will totally go obsolete or something, but maybe to some extent. But it will probably open, other venues of work, right? AI will probably open other venues of work which we cannot foresee right now.
I also agree with him. Do you want to add?
And I think it's one thing that we definitely fail on is like think about what would we be doing maybe 10 years down the line and so on and so forth. Are we still going to have such conferences? I mean, so are we I mean, like, so for instance, just think about it. All of you would have certain degrees of understanding of maybe the topics that are presented here. Now, what if we are talking here, and then each of you is going to hear things in your own lens, so to say, right? I mean, like, I might not understand what my fellow colleague here says because, like, I don't have understanding about radiology, let's say, but I get some extra information being poured into live. Maybe I'm wearing my something like maybe. Have you heard about the Meta Ray-Ban glasses? This is a pretty sleek device. It's not like a big thing that you wear the head top, where I can actually see things and then so it's kind of personalized. So maybe if I'm like so soon after this at 4, I want to go home. So let's say there's something that kind of, you know, it's not just Google Maps which will find out everything, but still maybe it will automatically figure out let's say what time to leave here would be best, so that I can probably maybe route me to say Ponmudi and then, you know, see that and blah blah blah. But so the thing is, like, we cannot able to, we are so stuck with the kind of ideas and that things that we have. So beyond that, let's say maybe for 5 years before, if someone could say that, you know, maybe I'm going to learn an entire course online and there's not going to be any lectures for the next semester, people will go nuts. But COVID came and then, you know, we did that. So it's all about the transformations which we cannot imagine, but things are going to take us to that level. So the leaders would be the people who can envision that now. Things that are so disruptive that can be assembled with superpowers like AI, and they can foresee that future which is not here, build right now, and then create a market for that. They will be the leaders.
Thank you. I think
this question is for Joseph. What are the most common challenges you faced while moving your research-based model to the production-graded model?
Yeah, finally I have a question that is not literally AI. Okay, that is great. So thanks for your question. Yes, when you move research models into production, there's actually a lot of things that you might have to do. Things like latency. In a research, let's say even if the model takes what 1 or 2 minutes to get process and get outputs, that should be okay. But a customer might not wait for 1 or 2 minutes even to get something really beautiful. That's one. The other one, which maybe like we did touch upon that in the medical field too, is like, you know, when maybe an AI or some model creates an output, there should be grounding. We just cannot give the output. For instance, like when people might use Acrobat for using consuming the PDFs, right? So Acrobat has this something known as AI assistant on the right hand side. You can ask for any question. The beautiful part is for each answer you get, you'll have grounding on what part of the document did it actually look for getting it. So that's a, let's say that was a neat technology from Adobe Research that got shipped into Acrobat, where of course it's an LLM, maybe GPT and so on and so forth, actually creating the output. But then we are able to attribute, and during that process we are just removing obscure outputs from these LLMs which doesn't indeed align with whatever is there. So I mean, like, so this is one, these are certain aspects, and of course data is so sacred. So your models that are indeed you do it when you do research, you might be pre-training on a lot of data, you might be consuming, like in an academic setting, that's not, it's okay to kind of, you know, use academic data sets for doing that. I mean, so does all the data that you have in academic data sets, are they, I mean, like, are they copyright free and whatnot? I mean, that's also something that is very, very important when it comes to maybe shipping your model.
Thank you.
okay. Thank you. I think we will take one more questions only. Not too many. We are getting out of time almost. Okay, let's do 2 or not more than that. Oh, here. Okay, let's 3. So make the questions shorter. Okay, this is my request. Yes.
So my question is, nowadays there are a lot of
the development is happening in a lot of space. So how to stay updated in this fast-paced AI development?
So I think that's a very valid question. If you are not updated, that means you are already behind this several technology. But then keeping refreshing our memory is also not that easy. I think good thing is to subscribe to archive. Archive is the one place before publishing papers people put into archive. And mostly in computer science is very open domain. So you can also read. Now there are open reviews are there where you can see how people are publishing. Go to the conference websites. Let's say CVPR, he mentioned ECCV, ICCV. There are ICML. There are other conferences in different domains where keynote talks or the tutorials are given on the recent topic, and most of them are completely open source and given for free in YouTube. More than that, I think you have to basically read newspapers, what is happening in and around, and then take the recent courses. Let's say now you can have time stamping in everything, so you know that which video has been updated recently. Like I today talked about CAN network. There are many new developments happening. So I think surfing, subscribing to there are AI news also there. There are blogs. I think you have to be a little more open-minded. Attend like seminars like this, like here, industry people, medical. So you have seen most of the age group, 30, 40, 20, like that. So I think each one have different perspective. Attending seminars, conferences, listening to lectures would give you some updates, and that's how you can be updated. That's, I think, the best way to update it. Otherwise, the university also should change their syllabus. If they keep on teaching the old stuff, you will not be updated. So it's also responsibility lies with the governments, the technical boards, and the institution heads, that they should keep on revising syllabus every 2 year, 3 year, introduce new courses, upskill their teachers also, because they need to be also know to teach other students. So I think it's a cumulative effort that would help you to build that.
So I have a couple of suggestions. So first of all, with the volume, it's quite difficult. So I can understand that lot of papers are coming out, and as students, many of them have complicated mathematics. Let's say newspapers and all are very short also, 8 pages and all, and it's written in a very condensed way. So maybe people cannot understand. Right? Young students, it's a bit difficult for them to understand. So first of all, there are a few foundational mathematical subjects that you have to identify and get strong in. Let's say linear algebra, let's say optimization. So this kind of subjects in probability theory you need to identify, and you have to build a strong base. Right? So 4 to 5 subjects are there. So you identify them, work hard 1.5 to 2 years to create a good base on those subjects. Then you identify the milestone papers, what I call. For example, the paper by Goodfellow, for example, the GAN paper, or Attention is All You Need by Vishwani, and this kind of papers, right? So the papers that are, for example, the UNET paper. Many people talked about many of us are using UNET. You heard the name several times in this day itself, right? So these kind of models that are sort of benchmarks. When you are doing at sequence to sequence learning, for example, RNNs, LSTMs, there is a sequence to first RNNs came, then LSTMs came, then attention models came, then maybe Mamba and all these models. So there is a sequence to it. So you have to identify these kind of landmark papers, and you have to go through these landmark papers after building your, not read everything, and then gradually you will find one focus in one direction, and there you will explore, inside that domain you will explore more and more papers that are coming in the top ranges. I think that should be your sort of the way you should proceed.
Thank you, Dr. Sapursi, for this good point of view on that. The question was very good for the students, and the answer is also to follow the path he suggested. Now, there are one more questions from.
Good afternoon. So my question is to every panelist. So there are many students like me who find both academia and industry equally fascinating and can't decide whether to go into academia or industry. I mean, you can transition later, but in a way that's that wasted your time and efforts. I mean, you surely would gain experience, but the transition may waste some of your years. And given the current AI scenario, do you think PhD is really necessary in the future? If AI is doing so many advancements, and if you're saying you should do PhD again, in what topics would be relevant in coming 5 to 10 years?
So I think PhD just out of your interest. I think PhD, if you are really curious, you should go for PhD. And PhD doesn't guarantee you any job. And PhD only guarantees that you understand one thing little more deeper, and then you can face challenges in life, smiling, always smiling. Okay, a lot of rejection would come, and still you will smile. So I think you learn to be little patient. That's what I think PhD will teach you. Another thing PhD will teach you that okay, how to handle one problem from a grassroots level and take up to a very high level. And if you can do for one problem, you can do for any other problem. So that training would happen to you. It doesn't make you also expert in that area. For expert, you have to work much more longer. Regarding job, I think again it's your passion. If you really want good money, go for industry, because academy, at least Indian academy, will not be able to pay you whatever you are desiring. Suppose you say I want 40 lakhs package when I start, it's impossible. You have some salary which is given by government, you have got that only. You may get good student who will earn more than you later. And so that's again the real truth. So you have to, unless the 8th pay commission change our salary so much that industry people get lower than us, that's not going to happen. So that's another thing. But I think choice is completely individual. I think better to take this decision in consultation with all your family members. PhD is a long-term commitment, 4 to 5 years, sometimes 6, 7 years also can happen. And if you get a job in industry and still you're doing research, I think you can choose that way. So I think personal interest is more important. There is no such a right answer for that. I think some people leave industry, come to academics. Some people leave academics, join industry. It depends on their individual interest.
Yeah, just 2 points. So you referred to that, like when you make a transition from academia to industry or industry academia, you're going to lose time or go things wasted. But that's definitely not true. Like you are gaining so much insight in whatever you do if you have passion for it. So I can give I was a software engineer at Oracle before I went on for my PhD. I mean, not for 1 or 2 months, but for 3.5 years. So after my undergrad. And that has clearly helped me during my PhD or research days also. The reason is like when I write my code, I will definitely make sure to check it to GitHub and then keep it version there. So tomorrow, if my advisor is asking for some exam, some ablation experiments, I know where to check out. Now, if I would not have done that if I was not a software engineer without kind of a training in the industry, so nothing is going to go wasted at any point. Second time, I think there's a strong negative sentiment around PhD. Doing a PhD, like you're going to waste 5 years, 6 years doing I don't know what not, but take it from me, it's the best time of your life. You're free to do what you want. And then if you're pursuing things that you are really passionate about, then nothing can be better. Like if someone asks you, you have an affiliation to say that I'm doing that, but what you're really doing there, you're doing things that you're passionate about. So, and then another major misnomer that people hear about, like specifically for people who are transitioning from industry to academia for doing their PhD and whatnot, right? Like you're not gonna get paid for the next 4 or 5 years. I mean, you've been getting paid now. Believe me, that's also a myth. Even good PhD students, they get to do a lot of internships in India, within India, abroad. I mean, and they can match up, to be honest, or go even beyond. So yeah, I mean, just be positive, follow your passion, and if your passion takes you to academia, okay, well, fine. If your passion takes you to industry, okay, well and fine. It's all about the fact that you should be happy at the end of the day.
I think we are already out of time.
Yeah, there's one question.
So okay.
Okay. So can you hear me? we should definitely appreciate this AI boom, and like we should treat AI as a companion. But at the same time, doesn't it cause many dangerous effects? Like people can literally misuse AI to produce false information. So like it can also cause many data security issues. So how do we look about it? Like how can we literally distinguish between real and fake information?
I believe any technology, so to say, has its goods and bad, and it's up to the consumer to kind of use it in a very logical way. That would be my one line.
You have to use technology to defeat the technology. So if AI can generate fake, it can also detect it is fake. So I think you need to develop tools, technique which can detect like cryptography. So many things are there. So that authentication has to be added. So that trust factor is also nowadays. I think government insisting upon AI model. If you are using AI model, they are a liability to keep that this image generated using AI. So I think it's kind of a watermark is being inserted so that you know that it is AI generated. So I think those regulations also has to be brought in so that this misuse could be minimized. But definitely there could be misuse that only can be tackled by technology only. You cannot do other things.
Okay, thank you. I think we could start first of taking questions. So now what we do is that we have a good discussions here. So I think we got professors and from academia and the industry from Dr. Joseph and Dr. Saptarshi. They have given their good opinions and different fields, different questions. Students have already. I hope they have grasped these answers, and it will really impact. This is also my hope that it will impact their life in future. So, in that stage, I want to just close this session with the hope that we will meet again in near future. So, thank you. Okay, so that's all for this session. After that, thank you all.
As we come to the conclusion of this event, I take this opportunity to sincerely thank everyone who contributed to its success. First of all, I would like to extend our sincere gratitude to our director, Professor Jain Murthy, for graciously granting permission for conducting this event here, and for his constant encouragement provided to conduct this event. His support has been instrumental in making this program happening here now. Next, we also express our heartfelt thanks to India AI Mission, which is under Ministry of Education under Government of India, for providing us the opportunity to conduct here this event. That is, they selected us for conducting this event here. So we would like to thank them. Next, we would like to extend our sincere thanks to our distinguished speakers, Dr. Keshavadas, Dr. Deepak Mishra, Dr. Joseph KJ, for generously sharing their valuable insights, time, and expertise, which truly enriched our program. Next, we also sincerely thank our faculty members who shared their details of research which is happening at our institute, especially AI-related research activities. Thank you for your effort and insights. Next, we express our heartfelt thanks to our Professor Anil Shaji. All of you know he is our pillar of support in our School of Data Science. So he always encourages us and support for conducting various events here. This time also, from the beginning, from the planning and execution of this event, he was there. So we also thank him. Next, obviously, our sincere appreciation goes to our HOD, Dr. Priyanka Majumdar, for her unwavering support and for always encouraging us in a friendly and approachable manner. Thank you, Dr. Priyanka. Next, we extend our special thanks to Dr. Zakaria Laskar, who is the faculty coordinator for organizing this event, whose dedicated efforts and coordination played a crucial role in successful organization of this event. Thank you, Dr. Zakaria. Next, our heartfelt appreciation goes to our IT team of ISAC Thiruvananthapuram for their excellent technical support and seamless live streaming. So, last moment only we approached them for live streaming, and without any hesitation they accept our request and they support us. So, thank you for our IT team. Next, we also sincerely thank our PA, Mr. Senju, for all his assistance, coordination and support provided throughout the planning and execution of this event. We also thank our participants. Without you, this will not be a success. So, your enthusiastic involvement and active participation make this event truly success. Thank you once again for all participants. We also sincerely thank our all volunteers for their time, dedication and selfless service, without which this event would not have been happened. So I would like to mention their name because some of them mentioned, especially to mention their names because it will be a motivation for our students to volunteer in future events also. So Uma Priyadarshini, Maitreya, Pranav, Mohammad Qasim, Muthu Manikyam, Rohit, Ashika, Abhinav and Tarshana. Thank you our volunteers for your support. Next, I should give thanks to my department colleagues. Obviously, we are doing organizing all these events together, but still I would like to thank my colleagues for their support and cooperation. Next, our warm thanks to our own students, our ISER students, for active participation, enthusiasm and commitment, which truly brought life to this event. So we are expecting your participation and support in the future events also. Thank you once again to all, especially all our speakers, our participants, our faculty colleagues, and our volunteers and participants and our students. So, with this, we conclude this event. Now I have a couple of announcements. First of all, tea will be served here, just outside this venue. And since we have a little more time, if you are interested, we can visit one of our research lab. So almost 1 hour will be there. Up to 5:30, you can visit the lab. So volunteers will guide you to the event, guide to the lab. Okay, so volunteers will help you to come back to the place where this bus will be there. So around 5:15 you can come back to the PSP just outside this building. So thank you. Okay, certificates will be sent as a soft copy within 2 days. Okay. Thank you everyone.
Too much thank you.